Oh, okay.
There are only three
So
different colors.
to answer the question, then yes, that's called a bifilar
It
configuration.
is bifilar, is it?
Yeah, when you take two wires and you wind them simultaneously, like a twisted pair from a network cable.
Yeah, like those bifilar pancake coils.
Right, and then you connect the end of one wire to the beginning of the other in the same rotational direction. They call that a bifilar configuration.
Right.
Okay, so just so you know.
Which is one of the secrets to the Gerard Morin washing machine motor / the actual PMH that was used in the Coral Castle build by Ed Leeds Scallon. Something that you should look into later. It's actually kind of connected to this in a way. Because if you're running a rotating wind and then a counter-rotating wind, you're taking the two and you're mashing them together using a compression of those two fields. And I believe that's exactly what was going on with the PMH and Gerard Morin motor. Just saying.
And my Rodin coil. That's actually one of the secrets is what you said, putting it in series.
Yeah, and the Rodin coil has counter wind in it just by its very wraps.
Right, without the interference pattern.
Yeah.
Right, so technically the Rodin coil is like a 13-filer coil.
Yeah.
Or it can have variations on that number, but it's a large number. It's at least 8 turns or more, 8 individual wires or more simultaneously wrapped, and they are all put in series in the configuration that is suggested by Marco Rodin.
There's actually there's a variation on Rodin's design that I'm actually using, which is 2 channels. So you put 2 separate channels in series, so they're lying on top of each other, but the 2 channels aren't connected.
Yeah, that's actually an ideal configuration, and UNG should definitely talk about that.
Mm-hmm.
So he can tell you about a 2-coiler split setup where each coil is effectively still bifilar, but
like you said, there's different fractals, different scales of the design that look different.
Right, and so in Rodin's design, you have an enormous amount of parasitic capacitance.
Yeah, it's not ideal. It's not the ideal geometry, but I know personally, Jordan from Alchemical Science was speaking with Marco Rodin, and they came to the conclusion that the geometry is close, but it's not the perfect geometry yet.
Okay, well, let me explain it this way. Imagine that you could maximize the factor that you actually care about, the total inductance, to maximize the strength of the magnetic field. What if you could increase your inductance by a tremendous amount, but almost completely eliminate the parasitic self-capacitance?
That would be ideal. That would be absolutely ideal. But I'm still learning about the Rodin coil, so if you have any suggestions,
this is where Gerald has something to say, because Gerald is winding a very different kind of coil than
no, Gerald is. I consider I call him the Lord of the Ring.
So in his configuration, what you're specifically looking at, which I don't know if you guys have gotten into it or done the explanation on star coil designs, but you have 2 conductors that are taking, in general, the total net vector force and magnetic flux path through the Lorentz transform is still going to act like that thing is a solenoid coil, like it's a round coil. You'll have a north in one part and a south in the other. And the great thing about a star coil is that you can change the geometry, is therefore changing the length of each conductive path. Each conductive path is a straight line, and it has a parallel conductor running next to it in a bipolar configuration, so that each straight line acts as a single inductor and induces a current into the second line.
It's interesting you say that it is able to produce both poles, because something that the researchers that I'm following in the footsteps of, Daniel and Erica Nunez, they said they weren't able to produce a north pole. But recently on stream, I was messing with the frequencies and power level, and I actually was able to produce a north pole, but it wasn't stable. Like it wasn't even between the north and the south oscillation, if that makes any sense. It was like south, 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 then a north.
Like, I don't know if you've seen the earlier part of the show. I've been using oscilloscope magnetometers and a variety of other equipment to measure these fields in real time. It's so much better than a compass or using a cell phone to try and take measurements.
Yeah, I plan on getting an oscilloscope soon. That's really a necessary part of the next phase, honestly.
Yeah, you don't necessarily have to have an expensive one. The probe is going to be the key here when measuring magnetic fields. You want a probe that has an extremely fast sensor. You could use a tri-field rectified coil arrangement to produce some kind of a sensor that you could simply rotate and get the perfect field geometry for maximum gain. Of course, there'd be almost no way to calibrate the damn thing, but you would be able to see your signal on the scope and tell whether or not it was higher or lower than some other part of the experiment. So at least you would get some comparative analysis.
We do appear to be getting the maximum efficiency of 155%, which is, I think, is pretty decent start for the coil. But it's not as efficient as the researchers that I'm following have achieved.
Now, when you say 155%, do you mean 155% efficiency, as in a 1.55 COP?
So yes, so it's getting it's doubling the voltage while maintaining and slightly increasing the current.
Do you have any pictures of this?
I've got videos on my YouTube channel. We've done experiments live on stream. I got I had old multimeters, and then I got new ones, brand new ones that are specifically designed for the frequency ranges I'm using, just to make sure, and I put an output and an input circuit that was the same exact components, with the same exact energy going into both, but they're not connected. I'm using a stereo amp receiver so I can control the power evenly. It's a very basic setup, but if you go on beneficence.tv or YouTube/beneficence.tv, you can see how I did it with, I think the video is called 155% efficiency with the Rodin coil.
Huh.
Yeah, I'm just curious how you do your math, because when it comes to COP,
well, like I've explained,
I don't know if it's right.
The numbers could be slightly off, just because multimeters, they're not exactly. Some of them aren't exactly 100% accurate, but apparently this one has been calibrated. So, and yeah, it.
You have to your frequency ranges though too, and that's a huge part of the thing. Like, so
you don't see the input circuit in this video though, so. But I do have an input circuit, and it's not connected to the coil. It's the coil's in channel A output of the stereo, and then the reference circuit that's not connected to the coil is in channel B of the stereo receiver. So we got the same amount of power. I even tested it. Same exact amount of power going into both circuits, only the one with the coil's getting more power. And you can see when it's in its frequency range, the multimeter doubles the voltage while maintaining the current. But outside of that frequency range, it's less on the output, like it's usually is. So it's really interesting. That right there is me demonstrating no pole, where you do have a magnetic field. There's also a clip in here where I demonstrate the monopole. And recently I did find the North Pole. It's in there. It's probably very, very tightly packed, though. But yes, I have a do-it-yourself guide. So if you're interested if anybody's interested in how I did this and want to try to replicate it, if they have the ability to do so safely, definitely check out the description. It has the link to the guide in there.
I like your work, Ben. I think that Rodin was wrong in a lot of different ways, but I like your work and what you've done.
I appreciate that. Yeah, no, yeah. I'm not saying Rodin was completely right, and I'm not saying that I believe him entirely, But I'm following in the footsteps of really the Nunezes and what they claim to have achieved. And so far, everything that my research has led me to is concluded that they were telling the truth. And it's remarkable. Just go on Breakthrough Energy Movements. I think it's 2017 conference where Daniel and Erica Nunez speak. They have some remarkable things in that presentation that they give.
Oh yeah, I've seen almost everything Danielle Nunez put out before it was stripped off the internet. In fact, I still have.
I'm
in my
so jealous.
System, a whole bunch.
I never got to see all that. I discovered them after their stuff got erased from YouTube. So I had to kind of piece together this. I had to kind of reverse engineer what they were doing.
I've been around since they started watching Roden and their first meeting with Roden, and when they started the POE and the whole 9 yards. I was in the whole beginning of the internet or the YouTube explosion in 2008 when Thomas Bearden was just kind of putting out some stuff. Bedini was putting out a lot of stuff, and people were getting involved, like Mike Powers, and lots of people were building all these coils and getting in.
There was a huge like not that long ago, like 10 years ago, people were building these, and then like a lot of people just stopped.
Well, I think my issue with Roden is anytime there's a geometrical coil, his name is slapped on it. And that's just not true at all. He makes very specific coils wound very specific ways. The geometry is completely different than, I'd have to say, 80 to 90% of the stuff that's out there. I'm not faulting.
Real quick, I just wanted to add an addendum here, which is in the description, which people can't see if they're watching the video. I am still learning this, and this is the first time I've actually built anything like this. So I got the waveform wrong. I was reading it as a sawtooth. It was actually square wave. So, and I did update the do-it-yourself guide to reflect that and add a comment on there. But it on the video it says sawtooth. Just ignore that. It's square.
Please don't get me wrong, Ben. I love your work. Like I said, I ain't dissing on you at all. I think.
No. I take that as a large compliment considering what you've accomplished. So, I'm just a newbie in all this. I didn't honestly think I'd be able to get it to work. And when I did, you can ask my girlfriend. I woke her up. I was like, I screamed. I was like, woohoo! It was one of those moments where I was just like, what? What is going on? Is this doing what I think it's doing? Yeah, it's pretty. Yeah, it's pretty incredible. So, and that's like a rush. It's an adrenaline rush, and I kind of want to do it again. So, let's build more. I want to see more people building these coils. They're not that difficult.
Well, I've built, like I said, 175 different geometrical coils. And
I want to get into some of the different coils that you built because I want to try to replicate some of the different ones.
Well, I was just about to say, I'm sorry. What is it? Magnetic. I apologize. I don't know your name. I'm just getting into your work. So, but the imposed Merkaba, I think I've never seen a coil like that before. And that I think has something different going on than what Ben's got going on, which is different than what I got going on. But they're all based basically they're all in the same principle, I think.
We're all on the precipice of fringe science. I mean, you see all these distractions on the news with SpaceX and Tesla, and that's all distractions. This is where the real science is. This is where the real industrial revolution is going to be happening. These areas.
Well, I think what I'm trying to say is one of the key factors, or two of the key factors in all three of these systems are spin and compression, right? Whether it's charge density or time compression, call it whatever you will. Refractive index, I'm not sure. Like I said, I'm still working on the theory when it comes to my system and everything else that's out there. But these three systems seem to have these three things in common, and they all do different. They have different qualities, but they all kind of do the same thing. So it's just interesting to me. That's all I'm saying.
Mm-hmm. If you've seen the documentary, I've been planning on streaming this, and I can't do it on YouTube, so I'll do it on my Twitch channel. I can stream documentaries and movies and stuff. If you've seen The Lost Century and How to Reclaim It by Dr. Stephen Greer, and I know what you'll say, you know, he's very controversial in some areas, but regarding free energy, his research in that area is spot on. And this I highly recommend this documentary for anybody interested in free energy devices and the history of its suppression specifically. And they talk about the 3 areas of promise for free energy devices, and that's plasma physics, torsion physics, and ball lightning, which is basically the same thing as plasma. So,
all right, guys, let's get a little bit back to some of the stuff here.
oh, he was muted. Yep.
I was just going to say that the other thing they mentioned is the only way it's ever going to get out is open source.
Yes.
Make
exactly.
public that you do.
That's
Absolutely.
why I released the do-it-yourself guide immediately. That's why I open sourced everything immediately. I think it's key. It really is.
So real quick, I want to know what's going on here. I'm going to play the video. So just let me know what's going on in this.
Okay, this was one of the early simulations that I did in 3D Studio Max, where because I was just seeing 3 coils, I put the vortex in. They're all pointing the right way. These space warps, and release the particles, and all I would get was this broken bike wheel, as I used to refer to it. And when it comes around, you see a bit of a figure of 8. And then somebody put me right if I'm wrong, but I heard somewhere that if electricity gets to one end of a wire and it can't get out, it goes back the other way. So therefore, in my mind, it was creating a counter-rotating field, which is where I did the other simulation and released the particles with 6 vortex, both 2 on each axis, going in opposite directions, and that creates that creates the macabre out of the balls, out of the particles that I've released just in a 3D simulation using physics simulation. And it was just for me, because I'm not a scientist, but what I did notice in the core of it, there are particles that can't get in the middle. I don't understand it, but it makes sense, because that's where I fix the ball, the magnetic sphere, and that, you know, that's where it spins. You know, so is there some kind of compression going on there? I don't know.
Is that Mercury?
Sorry, no, that's just particles, released in a 3D environment in 3D Studio Max, and there's vortex space warps, and there's 2 of them in counter-rotating fields on each axis. That's my later experiment, and that's all they are. And when you release the particles, the odd thing is, because they're built, those vortexes are representing my wires on my machine, you see.
Oh,
so that open space that you're seeing, I know this isn't the scientific term of it, but I have that in the center of my coil. I call that the null zone. Right in that spot, there's no magnetic field, there's no electrostatics, there's nothing. It's null. That's why I call it that, but I know that's not the scientific term for it. But yeah, I would think it's a result of compression. Yeah,
but I was just overwhelmed by the fact it was creating the shape of the macabre, which again, you know, you've got to think a little bit deeper about it, haven't you?
Yeah, that's an amazing simulation. That's awesome.
That's really cool.
But it's just finding people to talk to who can think a bit all over the place and sort of put your head straight, because when you're experimenting on your own and you know, you start to doubt yourself and wonder if you're just imagining things, but you're not.
I understand.
There were also particles.
When you think outside the box, you got to make sure you're not in an echo chamber. You're absolutely right.
Yeah, absolutely. Now, one of the things I learned as a calibration technician for 8.5 years in the industry is all about the kinds of crazy errors and mistakes that are easily made when taking measurements. Equipment errors, user errors, stray electronic fields, other contributing factors that one wouldn't even think about, like temperature compensation for certain conductors. You know, when I was initially training to be a calibration technician, we had an assessor in who ended up later buying the company, and this assessor, he asked me a series of questions, to verify that I knew what I was doing as a Caltech. And one of the things that he did, which was particularly interesting, is, he had two leads shorted at the end, red lead, black lead, just to 1 meter wires, connected to the input of a high precision fluke digital multimeter with 60 digits of resolution. And he had it set to the lowest range. So what he did is he hit null on the leads. He took out the positive lead. He held it in his fingers for about 10 seconds, plugged it back in, and the meter showed about 350 millivolts. And so he instantly asked me, why is that voltage there? Explain what's going on. And so we had a long discussion about electromotive force, about triboelectrics, about thermodynamics, and a variety of other factors. And, so without getting into the story all too deeply, it was funny to see that you can just simply hold a test lead, heat it up by a couple of degrees, and it'll generate a voltage, just like a thermocouple junction. And it's just something that's kind of overlooked, but measurement errors can come from anywhere. So the real thing is, does the apparatus actually work? And so what you're doing, Merkaba magnetricity, is physical experiments that don't need to answer that question in a less direct way. You actually have a physical apparatus, either works or it doesn't. I mean, that magnet ball, it could seize up or stop spinning, but if it spins and it gets going really quickly and it interacts with the mercury, then it's kind of like a black and white, cut and dry situation. So
yeah,
experiment is key.
Yeah, Jeremiah had to set me straight on a few of my meters that I was misreading.
At least we found the problems, right? Because
yeah, we did, man. We did.
You didn't bring those problems to me and look at with 8.5 years of experience because you had no idea. Like, you could tell that there was an issue. You brought them to me because you knew there was a problem, and that just tells you right away. Like, if you've got a suspicion, you've got this sneaking feeling in your mind, like something is wrong with my measurement. Chances are there probably is. So take a deep look in your measurements, and sometimes that takes just as much as the experiment does in order of design and just backwards engineering how you took that measurement and what kind of contributing factors could be there. But if you work it all out and you're like, nothing could possibly explain why I'm still getting what appears to be a force, so, or a weight loss, or literally anything else, or an extraneous extra current. If you're dealing with double the voltage and you have the same current, I mean, that's as Benefactor was talking about, like, that's pretty much, in that regime of over unity where we are seriously considering trying to do tests and experiments to verify and validate that, right? We would want to check phase angle. We would want to make sure that what we're looking at here isn't just an anomalous measurement error. So
exactly, and that's part of the reason why I built the reference circuit as visual confirmation, just to make sure, because I couldn't trust the multimeters. Like you said, I might need to consult with you to make sure. What I'm seeing is what I'm seeing.
Yeah, I'd be glad to tell you anything that you need to know about your measurement setup, and if you wanted to go on a private video and just show me what you've got, and actually,
yeah,
I
like
can
a
tell you
later
every
point, that would be good.
specification about all your meters.
Mm-hmm. For sure.
So, no, the whole thing is there's this problem. You have what's called effective power.
Mm-hmm.
Effective power is the best term that I've currently found, and I got it directly from Tektronix technicians that told me about precisely which series of oscilloscopes could measure effective power. So let me explain what that is. Effective power is the real point-to-point measurement. If you take a single cycle, let's say a 60 hertz AC sine wave, and you break it up into 10 million pieces, and you measure the current and the voltage at each point between those two pieces, and you generate a measure in watts. And so you stretch that out. So you got these 10 million pieces, and you measure every single one between the current and the potential. You have what's called effective power, because you've taken the thing, you've divided it into the finest scale. You have exact measurements. They're not averaged over time. They're not compensated like what a multimeter does. It averages. A multimeter will take, say, for example, 10 samples a second, or maybe 100 samples a second, or if you're using a good fluke multimeter, 1,000, 10,000, even as much as 100,000 samples per second with a handheld multimeter. But that's with fluke. That's when you're talking RMS. That's when you're talking really high accuracies. But an oscilloscope is going to give you thousands of times more data, and one that can actually measure effective power will give you the true input-output watts. So if you have 100 amps and you have 0 volts, how much power do you have? You've got 0 watts, because you've got 0 volts, and 0 times 100 amps is 0 watts. If you have 100 volts and 0 amps, how much power do you have?
0.
Exactly. And
So
so,
multiply by 0, I'll get to 0.
so if your phase angle between your current and your voltage completely nullifies out the delta between your current and your voltage, you're going to end up with basically no power. And so you can measure the two independently. You can say I have 10 amps and I have 10 volts, therefore I've got 100 watts, right? But if the phase angle of the 10 amps and the 10 volts is out of phase by exactly the right amount, then you're going to basically have like maybe only 1 watt, 0.5 watts, maybe nothing if they're perfectly out of phase. And so that's the catch. It's
But like the free energy community, I'm just kidding. I'm kidding, guys.
Well, the Nunez method specifically, I believe, works on the principle of 180 degree phase shifting. The two channels. You got energy flowing in one direction and energy flowing in another direction.
Yep, and that's key. But you also have to have a circuit that brings it back 180 degrees and turn it into real power.
I see what you're saying. After the fact, after that's like transduced.
Right. So here's the thing.
Whatever.
Instead of considering this like two parallel strings that are both completely synchronous with each other, you have to have a signal that travels down one side and travels back on the other. It's got to take that full path, and it's the time delay that it takes for it to take the path which generates your phase differential. And you can tune that by adding external components like external inductors or external capacitors to slow it down or to speed it up, depending on which way you configure it. But you can change the resonance of a system by using external components, and to perfectly tune it in, say if it's a mechanical motor like a magnet motor, you could tune it into a specific RPM to get the maximum gain factor. Or if it's an electromagnetic coil, you can use a set of external capacitors attached to a perf board and just bridge them as needed in order to tune that specific capacitance and get the right resonant frequency. So for whatever you need, you can always tune it. And that's what Tesla really was key at. Tesla's big discovery was he understood how to tune the systems in order to make them respond with the highest amplitude possible. And we should really be focusing on the same thing, whether it be the Graviflyer, the Gravity Lifter, or any of these other systems.
Yeah, paying more attention to the geometry factor as well.
Right, exactly. The geometry is critical.
Mm-hmm. I got a question, and it kind of goes back to what I said about Merkaba magnetricity and Bend system as well. I did a video, I'm not sure you've seen recently, Jeremiah, where I just used my signal generator from my function generator, and I put just the signal at 10% duty cycle on my primary, and I did the exact same on my secondary, and I lit a bunch of LEDs super bright. So my point is, with Merkaba magnetricity, he said it's run in series, and if it's in series clockwise and counterclockwise, kind of like what Ben's is that not voltage going against current, kind of like one signal crossing the other, creating a third signal, almost like interferometry? Am I explaining that correctly, or
Well,
you get
okay,
my point?
so I unfortunately have to make it even more complicated to answer your question.
Sorry.
So,
Sounds like an
God
interference
damn it.
pattern.
so to answer your question, the gain factor is coming from the cross-sectional interferometry of your conductors due to their geometric configuration and the angle that they are crossing. You have a certain amount of capacitance, but your inductance remains the same. That's the beautiful part about a star coil that's wound with layered stacks that keep rotating, is that layers don't end up adding on top of each other, so that net capacitance can't travel down in the longitudinal mode and couple to each next conductor on the layer up. And
Exactly.
that's the main key, is you've minimized your capacitance. You've reduced it down to about the maximum that you possibly can achieve while still maintaining a density geometry. And so here's the funny thing: if we convert your geometries in terms of a 24-point coil into a series of stacks without saying any numbers, you can jump a larger number of points to use a different length of conductor, a different length of antenna, and take up more space, creating a gradient geometry as your coils are stacked. And the gradient in the magnetic field energy that's concentrated as it's changing over time with a very fast back EMF impulse has a direct effect on the space-time surrounding the coil. And this is where the weird stuff starts to happen, right? Because now we have an effect on the space-time around the coil. What happens to the rate flow of time in terms of epsilon and mu as they are modified geometrically and twisted within the flux of this coil's collapsing field? It adds cyclically.
You're you picked up on something that most people haven't. Not only that, let me give you one more. If you were to take a series of my coils and the way that they're counterwound, if you went from primary or from secondary to primary and then primary to secondary, and you were to do that in series in a loop, and you were to take a tube and run it through every open core, you would create the most efficient particle accelerator ever known to mankind. That's a theory I have. Never done it, never will. But
Wait, sorry. Repeat that one more time.
so
well, don't say never will, because technically, okay, you've got the bell.
Oh, I believe anything
Not
Gerald
telling-
sets his
no, I'm
mind
kidding.
to, he can accomplish, man.
He knows what I'm talking about.
Yeah, I know what it rings. Let's just say that.
But no, repeat that just one more time. I need to hear it one more time.
Okay, so if you were to take a series of my coils, because they produce a rotating magnetic field in a linear fashion, and you were to wind them from secondary to primary and then from secondary to primary in a series configuration, and you were to take I'm not sure how many we would take, but you were to run them in a circle with a tube through all of the open cores, and you were to seal that tube, you would have the best particle accelerator known to mankind, most efficient, I would say, because
So
I
in
can
the tube, what would you put, like gas that you would ionize?
Yeah, kind of like the EPG, Stanmeyer's EPG, how he worked his system. I believe that if you were to take a series of these coils and build an EPG like that, it would be just absolutely mind blowing. It would be next level.
Yeah, no,
Yeah.
I'm definitely, and that I don't think.
If I
how
can get
hard
together
is it
with
to
it,
get? Oh, I'm sorry. Go ahead.
like you guys. If I could get together with a team like you guys, get Nathan out here, get Ben out here, Jeremiah, even Merkaba Magnetricity. I'm trying to get as many people as I can together. I think we could accomplish our goal within a year. I really do.
You know, it's
We
probably
have
not that
some of the
unlikely.
smartest people here.
I'll start my count for a second. So, yeah, I'm working on an interesting project right now, and it's not directly related to what you're working on, G, but this is the early version that I have. It's a wrapped toroidal core that's made of standard silicon iron or transformer steel laminations, and it's got 6 individual coils around it, and they will fire in sequence, one coil on at a time around a circular path in order to create a traveling eddy current that moves through the core, effectively creating a soliton. Now, the soliton can't exist on its own because once the core is polarized in a certain axial direction as the field travels around, it will stay polarized. So we use an external solenoid coil, and this is a bifather winding, in order to pre-polarize the core laminate material that's inside this. And so what happens is the iron domain nuclei inside this core are going to stand up in neutral position in the upwards direction because this coil is going to polarize them with a north on the top and a south on the bottom, causing them to stand up in the same direction as the center coil. But as each of these coils sequentially fires around the outside, they will tilt that field that's standing upright and they will twist it to follow the core. And so we'll have this traveling wave front where we've got a twist down in one direction and a wave front with a twist up in the other direction, and it'll sort of move around the core. And what this is going to do is create a tilt in the local gravitational constant because it's saturating the refractive index. But of course, the problem here is that we are using transformer steel, so that's not good enough.
So what is, for a layman like me, what is the refractive index?
Okay, so the refractive index is basically what determines the speed of light in free space. You know how gravity tends to bend light?
Right, and the speed of light isn't constant, so it changes.
Right, so the two variable factors that are most affected by the presence of gravity are epsilon and mu, and they are the electric permeativity and the magnetic permeability of free space. Now, even within general relativity, space being considered completely empty with no structure and no substance, it still possesses these two factors. And so they can be modified, and if you do modify epsilon and mu, you can use only positive energy to create a warp field. And Alcubierre didn't try to solve this problem. He used a negative energy or negative refractive index caused by negative mass in order to produce the opposite potential warp in the front of the craft. But Lenz came along later and solved the problem, mathematically showing that you could use only positive energy with differentials due to the regaging factor of the vacuum and produce a warp field using positive energy alone. Basically, you could use a set of antennas, a set of high-power radio transmitting antennas to produce a warp field.
Wow.
Now, there's actually a couple of examples of exactly this, and they show it operating and show it producing force. These two examples are PNN, or Propulsion Non-Newtonian, as translated, which is an Italian company, that produced a warp field antenna that they are saying is due to purely a Lorentz transform effect, and they can't explain the time variant factor that exists in this antenna. But basically, when they turn it on, it starts to produce force after a couple of seconds, and then as they leave it on for longer, the force that it's producing, even though the power input doesn't change, it continues to grow higher and higher and higher. The same thing happens with David Perez's system. He originally had the company Quantum Electrodynamics. I forget what they're calling themselves now, but
that name sounds familiar.
Yeah, David Perez had a warp field antenna in the early days that he was working on, and we finally got him on the Alternative Propulsion Engineering Conference that we started. And what he's got now is a pretty fantastic system that can just about lift itself. He's using spring scales, or a homemade spring scale kind of setup, in order to measure the amount of deflection that he's getting on this antenna as he powers it up. And it has the same exact effect as propulsion non-Newtonian PNN, that when you turn it on, it doesn't instantly produce a force, but as you leave it on, it produces more and more force.
Is there any time dilation effects that you know about?
Yes, there is.
That's
David
interesting.
Perez tested it with a laser interferometry setup and looked for a wavelength shift. And in that, he was able to demonstrate that there was indeed a temporal shift.
So this might play into this segment right here, but I am currently releasing a 60-minute video, a Divine Science special on a real-life flux capacitor. I'm not going to spoil it, but I think you guys will really enjoy it. I'm going to release it Saturday at 8 o'clock Eastern Standard Time, so I think that you'll find a lot of valuable information in there.
Man, too bad we can't get a preview of that, because I have 2 flux capacitors sitting and have been over there called solid
I
state
do have a trailer, but it will be released early on Facebook. So if you want to see it early, I'm going to try to release it either tonight or tomorrow on Facebook. But that's for members, and it's 99 cents to join.
The 2 of you have flux capacitors. I'm going to look for a DeLorean.
Yeah. I got to get in on this, man. Come on now. My daughter goes 88 miles an hour. I think we're going warp speed, dude. I keep telling her we're not time traveling here. We're just trying to get to the supermarket, you know?
Just really, really fast.
You guys remember that wild story of this dude who apparently connected some kind of output of a car ignition coil on one side to an antenna on the other, and electrified the outside of his car, and allegedly claims that he time traveled with this setup?
I would love to see it. I'm surprised he's not dead.
I want to try it. Never mind.
That's interesting. I never heard of that.
I was cracking up the first time I read it, and I seen it actually translated from a Russian article. I have to trace it back to figure out where the heck it came from. But yeah, apparently this dude sets up the ignition coil as like an antenna transmitter and electrifies the rest of his car with the opposite potential, and claims that he time travels like a couple of minutes or something like that as he's driving down this slope.
I don't know. It's possible. Yeah,
I'm not gonna say it's impossible. Okay, I'm not gonna say it didn't happen. I'm just, I was cracking up with the story. It's still like a very ridiculous, but highly entertaining story.
The setup sounds very simplistic.
It might be a shocking. It might be a shocking experience. Who knows?
Well, he also proposed it as a security system for the car. So.
Oh my God. Yeah, you're time traveling. It feels like the lights are going past you because the cops in the background pulling you over, man, as you're going down the hill. It's like smoking it out and trying to drive, man. It feels like you're in warp speed. It's all coming past you.
And every time you show up at Walmart, and you park your car, you come back after 30 minutes of shopping, and you come outside, there's like this pile of 6 or 7 people that are laying on the ground around it. And you're like, oh man, not again. I got to drag them out of the way to get out of my parking spot. Probably not the best idea.
It's like a community taser.
Just don't install a time machine on a Tesla. It could randomly time travel without you knowing.
Nah, this is the correct core material. This is something called super malloy. I've not got it quite terminated. You can see that the end of the lamination isn't pulled in, but I've got Teflon tape that should be arriving in just a couple of hours. So what I'm going to do is actually layer these laminations from one core to the other. This one is a blank core that I 3D printed thanks to Simon's work. And so I'll be respooling what's on this core onto this one, but there'll be layers of Teflon tape between. And at the center of this core, you can actually see the metal termination for the end of the lamination. And so if I Teflon insulate all the layers, I effectively have a solenoid to generate a net H field that I can use for magnetic polarization.
Is that what they call a circular magnetic field, electromagnetic field, and a circular with a circular construct?
It would be field? Yeah, it would be a circular magnetic field. Yeah,
it's circular, but it's not rotating. Is that correct?
Well, actually, it wouldn't be rotating if it was just continuous. But again, that's why we have this set of coils where we fire from one to the next.
Oh no, I get that. I meant the other one. Sorry. I know what you're working on. There's a lot.
No. So we have a static. Right, you're right. This is not a rotating field. So this is a static field, but induced into the core. Even though we have the field vectors pointing upwards, if we pass a current through this lamination material, they'll tilt sideways when the current starts to flow around the core because
so it'll tilt in the orientation of the current.
Right. So as they twist, they don't just simply twist and then bounce right back. If you get the frequency just right, you can get the twist wave up to such a high amplitude that what happens is it twists, and instead of bouncing, it actually flips. It goes the other direction. So it starts to rotate. But what it'll quickly do is it'll want to try to neutralize its net momentum. So instead of rotating and flipping around like that, what it'll start to do is a precessional motion. And with this precessing motion, you end up with a net type of field that is carried in the pure momentum of the relativistic mass increase due to the atom momentum of each individual electron shell that's precessing, and the nuclei of those atoms that are being carried along by that electron shell that's forcing the nuclei to precess. So it's doing this little wobble thing, and inside of that wobble, it carries a tremendous amount of momentum, and that momentum is actually carried around in a circular motion. So it tilts the gravitational force that this core experiences, in theory, and causes it to weigh less and less and less until its mass actually goes negative.
Would you consider that like some kind of centrifugal force?
You could consider it analogous to that, but
okay, so it's not. So just imagine it like a centrifugal force, but it's not exactly the same.
Right.
You're looking for a gyroscopic motion, correct?
Yeah, in this case, we're looking for if you had a symmetrical north and south on the bottom. What if you could create a really, really sharp pinch point between this north and south that were evenly distributed on the top and bottom? What if you could pinch them together at just one point? So if they're crossing each other and you can suddenly cause them to pinch together like this, you got this kink instability. And if this kink is traveling around in a circle,
is that when you create like a monopole?
It's effectively acting like a monopole.
A pseudo monopole.
In the axial direction. Yeah, exactly. A pseudo monopole in the axial direction.
You're compressing it just the right way, so you get just the outflow of ether energy.
Right. So because the space-time compression is so tremendous, what happens is you increase the energy density in the local space, you spin up the local nodes at the Planck scale, and so the ether actually expands outwards. And the speed of light is modified, and it moves faster in that region because the nodes and their distance is expanded in that region. And so you end up getting a redshift onto the outside, which means that you're absorbing energy from the outside into the system.
Right.
Your and mine work, your work and my work are very closely related. They're not quite the same, but closely related. I love what you're doing, Jeremiah. That's awesome.
Yeah, they should really cross paths, and most of this stuff is all about crossing paths anyways, magnetically, electrically, or otherwise. So
exactly, and that was my point about Merkaba, magnetricity, and Ben's work. We're all doing the same thing. There's like this underlying truth amongst all of it, right? Just like I hate to bring up this reference because it dates me, but in Ghostbusters, what do they say? Don't cross the streams.
Don't cross
and then in the end, what do? They cross the streams. Okay, so like
but not only that, Gerald,
how they win the final battle is they cross the streams.
Not only that, Gerald, I have to commend everybody here for their work because we're going against the mainstream. We're going against the grain here. You know, we got people. I'm sure I have people who are telling me I'm insane. You know, I don't know what I'm talking about. You know, that's impossible, stuff like that. And we need encouragement, and this is
I'm
what
used-
these.
Sorry.
So originally,
No, go ahead.
I went under the the name "It Is Possible," and then I later changed it to "Break the Limits." And I'm currently using exotic propulsion on my channel, but I don't post even probably 5% the stuff that I do. So I have a tremendous number of experiments. For example, like that 6-coil system that I just showed you, here's the step sequencer for it. So it's just basically each step it moves through and fires a different coil. So only one coil is on at a time, and the back EMF from the last coil's phase collapse meets the front or the forward EMF of the next coil's phase build. So the two end up creating this sort of pinch point of magnetic fluxes right between them, and because of that sharp transition in magnetic field, you get the spin polarization. And
So that's your H wave right there.
Right, that's your H field.
Oh,
So
that's
hold
cool.
on, how different is that than the other one we saw? A gentleman just died, and he was using a field to turn it on and switching, and it would only go on at a certain time and then switch off and on. And he was trying to get rid of the I forget the back force of the EMF or whatever he's looking at of the actual magnet in doing
Probably
it.
anti-lens law would be my guess of the term.
Yeah, and then John something or am I
Well, you
close?
got John Bedini was the guy that did.
No, different.
Okay.
Guy had a long hair. He just passed away probably about a month ago.
Joseph
Maybe a
Newman.
little bit more, but it had to do with the lenses law, and he had this big giant machine that was in his garage.
Was it Joseph
and it was
Newman?
like 4 foot by 4 foot. I don't
Yes.
think it was.
That's Joseph Newman. You're talking about it's like a magnet motor that's been turned inside out, correct?
Let me look it up. I'll look it up while we're talking right now.
I maybe I'm wrong. I think that's what you're describing. I think
That's
Ben's
the
got.
only that's the only guy
No.
that I know who has long hair.
No, we're talking about somebody different here.
Yeah, you know what? It must be because Joseph Newman passed away quite a while ago, actually.
Oh, really? Oh.
Yeah. So
Yeah, I don't know.
Somebody else, yeah.
Somebody knew
Sorry.
me. Yeah. No, it's okay.
I've got no idea who it might be.
Who?
Nathan will get to the bottom of it.
I'm looking it up, man. I have it saved somewhere, and you guys go ahead. I'll look this up. It was just a really interesting.
no, I hear that. I got 5 terabytes of scientific videos and PDFs and file. It's insane. So sometimes when you're looking for something, it's really difficult. Like I'll give you for instance, Nathan, the Steinmetz book. All I have it on is video. So I'm reading the book very slowly, like you can scroll through the video. But it's basically like that's all I have of it. I don't have the actual PDF form of the book. So if you want that, I can email you that.
Yeah, I love one of those ebooks that reads it for me, so I can sit and do work while I listen to it.
Oh, I hear that. That I don't have.
Get
I got
Speechify. Get Speechify. That's good for that.
Can you run Speechify with PDFs?
Yes. You run Speechify
So, like,
with
if I-
anything. Even if it and it should run, but if it won't, just copy and paste it into the Speechify program and it'll read it.
Because I got like T. Henry Morey's book, and I got Walter Russell's book, and Hutchinson's book, and by
Yeah,
George
that's what I
Hatt.
do. I just use Speechify for all my audiobooks or for all the books that I want to read to me.
That's awesome because you know what? It's really hard to read them all.
Yeah. Yeah, it is. It's hard to find time too when you're so busy, trying to pay the bills and all that. I understand.
Pay the bills, experiment, and build devices that you can sell. Like right now, I'm working on a chain bar lift. Well, multiple chain bar lifts in one system. So
I still think we could all start a business. We'll think of something. I think a good viable business might be starting with selling coil frames, but who knows?
I'm working on opening a business that lowers the solar footprint. So rather than like say you have 5,000 watts of solar panels, well, most people don't have enough roof for 5,000 watts for one,
Right.
and
So
for
you
two,
increase the efficiency of the photovoltaic
not so
process.
much. More like the way of the design on how uh, it's displayed. No, that's not quite the right word. So most people put solar panels on the roof. Well, I've got a system where it unfolds,
Oh,
and
so
because
it's also it would be less um sightly
it's
and
very
more compact. Yeah.
yeah, and in fact, the way that I designed it, you can stick it on. I wouldn't recommend a roof that's a bit high. You could stick it on a flat roof shed. You could stick it on a trailer, a boat, like what's the word I'm looking for? Like a barge. You can get on a barge. There's a lot of things you can do with it, and it literally raises like a tower, and it turns slowly with
I
the
honestly, if you find an investor, and I think you will eventually, that's a great idea. So I wish you luck
yeah. I've
with
already
that, and I
built
think
a
you're gonna do good with it.
I built a small prototype and tested it, and it worked really well. So now I've purchased. I spent quite a bit of money, but it was worth it. I
It's
got
a good
720
investment.
watt solar panels. They're huge,
Oh wow.
and so the big prototype is going to be an unveil very shortly.
Yeah, it's an investment. We all make them. They're calculated risks. It's all.
Yeah, and hey, if not, doesn't matter. I'll have solar power for my house.
Right. Right. Yeah. So there's always a good side. But no, I think you're doing good with that, and I think you'll succeed because that's a good idea. And a lot of people, especially the people who have money and don't want those unsightly solar panels to be unsightly, have the option of folding them in and all that.
Yeah, you can fold them in at night, charge your batteries during the day.
Hmm.
Then that way you don't have to worry about like preppers uh, kind of think in the way that in a grid down scenario, people are going to be looking for you and they see the solar panels are coming to your house. Well, what if you could just hit a button and your solar panels fold down? Nobody knows they're there.
Right. Right.
You know,
Right. Yeah.
the
No, that's
added
exactly.
feature. Yeah,
Yeah. No, that's great. No, just keep thinking of good ideas like that. I think you'll succeed with whatever you put your mind to. Honestly, Gerald, you're really smart.
appreciate that. I'm not so sure, but I appreciate that.
No, no, I am. You gotta have a little faith. Gotta have a little faith.
Well, I got a lot of faith. I just need a couple pennies to rub together in order to make some of this stuff happen.
Yeah, and that's a problem. You got to learn how to market yourself, especially if you're doing it on YouTube. It's triggering the algorithm's tricky. Trust me, I've tried everything under the sun, and I think I'm finally starting to get and understand the algorithm. But once you learn it, and learn how to trigger it, I think you'll have a little bit more success.
I remember this guy.
I found it.
Yeah, he sort of disappeared
He
right
died.
after.
Oh wow!
Oh,
Yeah,
he
I've never
died.
seen this guy. Who is this guy?
It's an interesting system.
Defeating lens law. I have a chapter in this in the Practical Guide to Free Energy Devices that we went over.
Yeah, so as this device turns on and off things, switching on and off the coils there, and then it goes, turns it off and it goes to the next one, picks up. So you never get the back EMF to hold back the magnet. It continuously pushes it on and
Huh.
on and on. So it goes really fast as a motor.
Wow.
It defeats Lenz's law.
Yep.
That's why I was saying the switching, it's almost saying in what Exotic was doing is
Yeah,
it's
almost
switching.
identical actually. The way that he's switching each individual segment there, just one at a time, in order to pull that thing along. Although he's switching technically both sides opposing, so he has two shifts in the local refractive index. But in my
So
case,
left and right are off, and then center's on.
So if he
right.
wasn't
So,
if he wasn't defeating lens law here, what would it be doing? Just going back and forth and almost stationary and not moving all the way in a circle?
Yeah,
Well,
but that's
the
sorry.
catch is that you have a field conversion in your solenoid coil that chases the flux through the core that's orthogonal to the electric field being produced by the core. And so because the solenoid coils wrapped around the core are just producing the polarization within that core material, the core material's field is orthogonal, and so the way that it interacts is a little bit different, and it sort of breaks the phase angle coupling coefficient between your driving coil and your stator coil.
So like from a layman's term, you would basically say he's pulsing it so fast he doesn't give the system chance to have the magnetic field build up enough in order for it to slow the system down, so no back EMF can be created.
Right. He's only
Am I correct? Yeah.
what he doesn't want to do is specifically force the domains to stay in a tilted position. If you take even a laminated iron core like what he's got, or a laminated transformer steel core like what he's got, I believe that's what he has in that system, is a sort of toroidally wound core. It could just be a solid core. In either case, what you'll end up with is a bunch of domains that can twist, and if they get twisted into a new angular position, they'll stay polarized, so they'll hold their magnetic field. Sort of like if you hold up a magnet to that core and then you put a compass near that point, you're going to see whether or not you held up the north pole or the south pole towards the core. It'll hold on to the flux to some extent. So you want to try to keep it just below the threshold where the flux stays stuck, and during the back EMF impulse, you depolarize it so that you end up with a really sharp wavefront.
That's actually one of the principles I use in my coil. Very
And
fast
you
pulse
did.
rate and very fast not rise time, but lower. I basically pull the energy out of the back before
So
I can even.
you're pulsing it so fast you're not giving it time to oscillate backwards. It's just kind of
Exactly,
inching
and
forward or
because of that, I'm giving it also a path of least resistance at 180 degrees out of phase, so that I can pull it out before I restart the next pulse.
All right, so specifically what he's doing is even speeding it with a square wave or even at 10% duty cycle, the rise time is always longer than the fall time. And what that means is the net energy differential in terms of the stress energy momentum tensor of space time is always pointed inwards towards the system. It acts almost like a gravitational force because on the back EMF impulse, it radiates electromotive force and expands the local aether density, and that will cause anything that's traveling in towards it to blue shift, and so it can gain energy from the external environment. And so he could technically, I mean, if he ran it correctly, he could get the thing to cool down or do various things like that, I would just suppose.
I have, but it remains to be peer reviewed by you and a few others. Like I said before, I'm now at 39 coils to give out. I'm not sure if I have that many on the list yet, but there's quite a few that it's going out to. So, very near future, I'm praying. We'll see.
Well, you know
buy
what
me
it
a
will
lot
take.
of multimeters for that thing, man. I wonder if they make a giant one with like 10 of them in it.
Oh, they do.
Oh, they do? Oh, I gotta get me one of those.
Yeah, me too.
Yeah, they go under the category of data acquisition systems,
Gotcha.
and you'll find them with capabilities of measuring temperature on many channels, voltage, current, whatever. And so what generally they do is it's sort of a cheap escape move, but they'll sequence through each of the channels and take a little sample for however many you have. If you have 10 channels active, it'll take a sample of each of them for 1/10 of the time, and it'll display you that number. And so for the rest of the 90% of the time, they'll miss it. But if the sampling frequency is much, much higher than the oscillation frequency, it's not really a problem. But the closer that they get to each other, the more the error increases, and they can get to a point where the measurements are basically worthless. But they do sell them. They're available, and they're not insanely expensive. They're not unaffordable.
Are they considered scientifically acceptable? Or is it better to have like?
No, they're considered scientifically acceptable if you get them calibrated.
That's fair.
Yeah, with any good scientific paper, you're going to have some kind of traceability. I mean, I've seen a lot of papers that do crude experiments, and they just put out these papers purely because they came across something interesting, and are like, so I'm a student at whatever university, MIT, Cambridge, wherever, and I stumbled across this interesting thing. Let me write this paper about it. And so that kind of stuff comes out all the time. We've had it with graphene and metamaterials. We had it with brothine. We had it with the LK99 alleged room temperature superconductor. I replicated that stuff, and so did Michael Perrone and a few others. And we've got our own opinions on it. I won't get into. But anyways, yeah, I mean, these little ideas pop out all the time. But the question is, can we actually put them into some kind of functional, replicatable format? And so the idea of the scientific paper is, I'm going to tell you what I did and exactly how I did it, what equipment I use, and then you go figure out if this has any validity. If a scientific paper has that or contains that level of specificity, it tells you what equipment was used and how the test was done, then it can be independently validated, and it becomes scientifically valid at that point after peer review, because there's a possibility of peer review. What I'm seeing, though, from academia is terrible, and it's a shame, because you would expect this from the fringe community, but instead, no, mainstream academia is providing a huge number of papers that are purely mathematically based, with no experimentation done and no proposed experiments.
We call that, where I come from, and paid for.
Yeah.
Absolutely worthless to any of us in the lab, unfortunately.
Yeah,
I mean, actually, I shouldn't say absolutely worthless. I would take that back, because the truth is, I've read a lot of those papers, and some of them do contain some interesting ideas.
But we do a lot of talking about, like theory can only bring you so far. You have to actually experiment with your ideas, before you start to learn and develop your theories, or else you're just going to be stuck.
Right, exactly. And
Yep.
a lot of this stuff has just led to dead ends. For example, Fran Aquino is an interesting case. I guess he has somehow collaborated with doing experiments, but I've replicated a lot of Fran Aquino's proposed diagrams, and when he writes a paper, he proposes a physical construction of a device and provides you the voltages that you need, and the spacing, and the level of vacuum, or whatever conditions, and whatever light source. He tells you about each of these factors. And so I've actually replicated many of his devices, and I can tell you for sure that they do not do what he claims they do. The level of force is several orders of magnitude off.
Wow.
And it's a mathematical error. I can kind of see how he made it, but I'm no mathematician, so I'm not going to get into where the error was made. But yes, it's several orders of magnitude off. The force is extremely weak, but it does have the same phenomena of being a cumulative effect. Why is it cumulative? Is a question that, when we can answer it as a community, we will understand how to make as much anti-gravity as we could possibly ever desire. We will understand how to bend space and time when we can accumulate energy in a local space. That will
I
be
would take that one step further and say that free energy in general is freedom. It will allow us to break the binds that have chained us for a long time.
Absolutely.
Yeah, I think what Jeremiah is trying to say, though, is when you get anti-gravity, you have to have free energy. You can have free energy without anti-gravity.
Oh yeah, for sure.
You,
Yeah,
to
it's a
accomplish
must.
anti-gravity, free energy is part of it. It has to.
But this is an exciting time, because I was just talking to Nathan. Like when he finally gets his Graviflyer working, he's gonna build a big one. And we're gonna fly around the solar system.
I can't wait to see that.
Get me out of here.
Yeah.
I'll record it on video. You guys leave it, and then I'll build mine.
Dude, this is gonna be so cool. Hey, what's going
What's
on,
up,
Bernie?
Crypto?
What
I
up,
finally
Jerry?
made it. How is everyone? Great conversation. I've been listening.
Yeah, I can actually hit present now. Let me try to see if this is going to completely crash my computer.
So for
It's
those who
actually
are
quite-
just listening, Crypto Alchemist has showed up, aka Bernie. Sorry, I just had to do that.
Do it while the audio still works. Okay, so here we go.
Oh, hold on. We got
see.
some presentation popping up. You want me to put that up?
Yeah, put that up. I'll show you. This is so much earlier in the show. For those who missed it, I spoke about trying to communicate with the deceased Nikola Tesla and ask about how he built Wardenclyffe's tower. And what I got as a response was a series of diagrams in my mind, and I proceeded over the next day to build it. And instead of the normal purple white sparks that most Tesla coils produce, you're going to see in this video the contrast of the white in the spark gap and just how red these sparks are shifted into that wavelength. And so I'm going to go ahead and play this video here.
Wow. Is it interfering with the camera? Is that what's happening?
It's my bandwidth.
Oh, it's your bandwidth. Okay. I was like, is it interfering with the equipment? That's crazy.
No, it
I've
actually
never-
it froze on my end too. Actually, the video froze on my end.
I've
but
never
you
seen a
can see
discharge
here-
pink like that. Or is it red? You said.
Yeah, it's pinkish red, and I've seen it get fully red and actually go orange as well, which is super fascinating. So I'll stop my share for now because that's obviously not working. I'm going to try to find a picture of the orange spark just because my video seems to be incapable of actually.
Now, what was the orange spark doing again?
Well, the thing is, the output is coming from an aluminum terminal. I also tested it on a stainless steel terminal, and that
Okay.
steel terminal does the same thing every single time. It's always the red, purplish red spark that turns orange at the base. And the reason for why it gets so damn hot and why the energy is concentrated so high has to do with the voltage or the ionization potential of the atmosphere. So normally it just ionizes nitrogen. A normal Tesla coil will ionize nitrogen and other atmospheric gases that are easier to ionize. And so that's why you get these brighter colored sparks. But if you can actually ionize the oxygen and then break apart the molecule, you can ionize singlet oxygen and you can get a reaction. And it's
Right.
extremely in the red spectra.
Hold on.
It's
That
easier to ionize the noble gases rather
Oh, oh.
than with the
hold on.
stable.
That has to do with the stainless steel.
No, it doesn't. That was my main point, is that it doesn't matter whether I use an aluminum terminal or a stainless terminal or a steel terminal. It does the same thing every single time, which means that this is
Okay.
not metals flying from the terminal. This is actually an atmospheric phenomenon. And that's how I ruled it out, is by using different terminal conductor metals in order to guarantee that I wasn't getting vaporization of metal particles.
Gotcha. There's a specific reason why I was asking. It was Alexi was said to use stainless steel in his all threads instead of what do we have now? Something else, some kind of metal coated with zinc or something.
Yeah, I think he's using galvanized steel for his
Yeah.
center plate.
Yeah. So that was just, if it was something different, I'd like to know. You know what I mean? So if there was a change I had to make, I'd do it.
Oh yeah, I definitely hear that. Well, I have so many pictures of this damn thing, but can't
Let's
find
see
the one.
some.
I can't find the one with the red spark. Well, there's no easy way for me to scroll through it. I have to actually open up each one independently and then click share screen every single time. So I'm just trying to. I'm bumping through them. Yeah, for some reason, Mac has this built-in function called Quick View, and you can simply view a video or an image, and you can scroll through the entire folder that way. But unfortunately, there's no way to share quick view because it's a built-in secure feature. So in order to actually share a video, I have to open that video in QuickTime Player, VLC, or some other video player on a Mac. So I'll go ahead and present this too. You can actually see that it goes red at my fingertips, which is close enough.
Okay, I don't have anything yet.
Not yet.
Oh, thought I was missing it or something, man. I'm going crazy.
Kind of
No,
like our
now
ball,
you'll have it.
kind of like our ball lightning videos, eh, Jeremiah?
Right. Yeah, we did some pretty good work on ball lightning. Okay, so I'll play this. And so those are my
That's
fingertips.
cool.
You must have some nice holes in your fingertips.
No, you don't really feel this at all, which is really interesting. It feels hot. It feels like it just kind of feels like you have a really bright light shining on your hand, and it does make your nerves twitch a bit, but that's because there is a huge amount of potential there, and so as it contacts your skin, it actually turns into current, and that's why you get the color change in the arc.
And this is from your Tesla coil?
Yeah, this is from the magnifying
Oh.
transmitter that I built based on the designs that popped into my head when I asked Tesla how to build the magnifying transmitter.
Well,
in
let's
my
hope
mind.
that
That's
Tesla's on
awesome.
my side this coming Monday because I'm going to shock the living daylights out of myself with this. I'm going for it, man.
He's going for it.
We're doing some high voltage, man. I'm going to hook up my Tesla coil. So is that AC or DC so I don't kill myself?
Yeah, that's all AC, and it works pretty well, so no major
All right,
shock.
here we go.
Are you gonna
Old
live
man
stream
Bill's
that?
going to get nuts in his garage.
Nathan,
What's
are you
that?
gonna live stream
Please
that?
do live stream,
Yeah,
so if
that's
you
one
do
thing
get
for
zapped, we
Neon
can
here.
call an ambulance for you immediately.
There you go. Call the ambulance for me because, man, I'm going to light it up. I got all kinds of good electronic toys in my garage, man. I'm going to light some stuff up.
Yeah, it's about time for me and my girlfriend to go back over the CPR stuff and
Yeah, for sure.
Safety first.
Better call a
Yep.
medic first.
That's why.
oh man, let me grab this thing real quick. You guys will love this.
I don't know if you noticed, Exotic, but when I did the testing with the neodymium sphere, I grabbed my hard hat. I didn't know what it was gonna do.
Oh my
Oh,
god.
that's funny.
Yeah,
I
no.
don't know
like,
the hard out. Oh yeah.
like I was afraid it was gonna fly up into the ceiling.
Wow. Yeah, I'll tell you what. One hand at a time. Keep the other hand behind your back, or play pocket pool. Do something else, but don't get it anywhere
Oh,
near
the one
that
hand
other
rule.
end.
Yeah, I was just reading about that. So you put one hand in your pocket to eliminate accidentally touching something to complete the circuit or whatever.
Okay, let me tell you a story. Okay, I built a voltage multiplier to my AC flyback. Okay, 24 volts going in. I made the mistake of grabbing one side and grabbing the other.
Oh,
Okay.
boy.
Oh man, I lit up like a Christmas tree. My hair started frizzing a little bit, man.
Like
I was
Chevy
like,
Chase.
oh god. I sat down and rethought my whole life. You know, it was just awful.
Oh,
It was
wow.
nothing like the little shock you get once in a while. You go, ow, that's okay. No. This was like life changing. It reminded me of the time I was playing my circuit breaker out back, and I had put the top of it, I laid it down on my head, and I was playing with the breakers like a moron. Okay. And I took some kind of a voltage return that zapped right through my skull into this thing and made the loop. Thank God it did, because if it just stayed in my body, I'd be dead.
Do you wear any kind of do you wear insulated boots or anything like that when you work around high voltage? Or
Nope.
Nope. So I know some
I-
people they'll wear like insulated boots or insulated equipment. I wonder if it even helps though.
Well, we're not talking super high amps here with the volts. So, I mean, we're in milliamps with volts, so it's relatively safe, but not really. But
So it's still gonna push you back a little bit.
yeah, it's it would be different if I had higher amps into it and then high volts. Then it's a death ray. It would just kill you. There's no getting around that. You're just dead.
I
Yeah,
had a
right now
friend.
it's just gonna bite you and bite you hard.
I had a friend who grabbed he grabbed an extension wire at work that was exposed, and it fried his arm to the point where it just like all the nerve endings were just constantly in pain.
My dad used to tell a story. He worked in the mines, and when they would set up a new mine, they had to run all the cabling and the 220 and stuff. Him and his buddies, they used to do this as a joke. I never understood that this was funny, but if you grab your buddy's arm, and I don't recommend this, let me say this right now, nobody in public, please do this. You grab your buddy's arm and you grab the 220 line really quick.
Oh,
You'll throw your buddy 5 feet against the wall without really hurting him. But boy, it's a kick. He said he had it done to him 3 or 4 times. So
Boy, it's a
one of his
kick.
buddies. I don't recommend it. I'm just saying.
what's an explosive shock between friends, huh?
Right? I don't know. They must have been good buddies, I guess.
I'd say.
I don't let
it's a
anybody just shock
shocking
me.
My dad miswired the shop out back. It was a 2,400 square foot metal building. So every time you touched the doorknob, you'd get shocked. He misplaced something on the neutral or the ground or something, and he thought it was the funniest thing because he was used to it, so he opened it up no problem. With the rest of us, oh, you go near my shop, you're gonna get zapped. You can't play with my tool.
Here's the defense mechanism for you.
Oh man, it's so great. Yeah, voltage is fun, man. Oh man, did I ever have fun lighting some stuff up with some high voltage like a year ago? God, that was all I was doing was lighting everything up. If it came in, I don't care what it was. It was trinkets in the drawer, man. I lit it up. So
I hear that. When I first started experimenting with the big coil that I show all the time, I used to load capacitors, like just little 25 UF 100-volt capacitors, and I'd get it right up to about 85 volts, and then I'd wait for my wife to come walking down the hall, and I'd just tap it, and the thing would explode. It sounded like a shotgun shell. She'd jump every time.
I'm surprised you're still alive after that.
I'm surprised I'm still married. Never mind.
Oh man, my wife's gonna buy me a fire extinguisher for Christmas and my birthday and every other occasion after what she sees next week.
I'm gonna buy her one for her birthday, just so you don't burn down her house and she has a husband and stays alive, right?
Maybe a fire suit to go along with it just to save him after. I don't know. I'm just kidding.
Oh, I got an emergency shut off for the power, man. So if she comes in and I'm half dead, there's a big red button.
Nice.
Be flopping like a fish on the floor. She come in and visit me. Hey, here's your dinner. Oh my God, what happened to Nathan?
Yeah, all you got to do is grab a handful of this thing. This is a
Can
nice
we
little
put that on
bipolar
big
test coil.
screen?
I don't know how to do it, Crypto. Do you?
Just at the very bottom of where there's like each of the screens of the presenters, you just like click on it, I think in like the top right or left corner, and it'll say solo layout or highlight.
Okay, I don't have that. Hold on.
Oh.
Let me solo layout.
There
we
you go. See? Looky what we have there.
So it's a basic bipolar Tesla coil, built on a classic wooden frame. We have 2 arc terminals at the top. I've got it connected to an ungrounded lithium-ion battery, 8.4 volts going into it. And this is a DC-driven coil, so it's basically the first 2 of 3 stages of the multiplier. And because it's a DC driven coil, it does generate a plasma rectification at the terminals, but you'll hear it. And I apologize ahead of time for the sound down there between those two shiny screw terminals here and here is the spark gap. So I'll turn it on for a second. So you can see the spark gap.
Very nice.
So I'll go ahead and connect that wire
Yeah,
again.
that's really cool. That is really cool.
And I'll spread the terminal distance out. So again, sorry for the sound. I know this thing is probably the most annoying sound in the world.
Fun with plasma.
But the weird thing is, what you can't see on camera is the smell in the air. So
the ozone being created.
It's
right?
ionizing a whole
Yeah.
load of ozone right now.
Yeah.
And the reason is the extremely high potential. So when the primary coil impulse fires, it's coming from this big red capacitor bank right over here. And all of these are ultra fast polypropylene capacitors, and they're ran in a parallel chain configuration. And then I've got two compensation ceramics just to deal with the impedance mismatch of the primary coil, because I have to go a full turn instead of a half turn. And so these capacitors take care of that. And then it's being powered by a DC ZVS driven circuit that has a full wave rectifier that's right here. You'll recognize that blue capacitor ceramic and the high voltage diodes that are surrounding it as a very crude full wave rectifier. And, overall, it works incredibly well. I mean, the key to this coil working so well, the thing that I discovered is exactly what we have read about years ago. Thoriated tungsten electrodes allow the system to run cold. So this spark gap, you would expect the spark gap here to get hot while it's operating, but it stays virtually at room temperature. And I've had circumstances where if I balance the impedance and the phase mismatch of the secondary just right, these terminals in the spark gap will actually get cooler than room temperature. So how can that possibly happen? You know, how can we lose thermodynamic energy to two thoriated tungsten electrodes that are 3 millimeters in diameter with slightly rounded tips? You know, where is the energy?
Yeah, you must be accessing the vacuum and creating cold electricity somehow.
Right, which is basically why I was looking at this simple setup and I'm like, oh, I can hook up a battery to this and demonstrate this for you guys. And
that's really cool. That just shows you there's multiple different routes to get to the same solution of free energy. You know, there's so many different ways and so many, and even basic circuits, and that's something that I learned recently through, you know, the works of John Bedini and all that stuff. But
exactly.
You know, it was mind blowing. Like, just ignoring the scientific consensus, the mainstream, you know, way that we are taught. You know, those little rules that people like to ignore, that create instability in the system. And then Tom Bearden comes out and says, no, you want that instability and you want to use it.
I don't know if it's related, but when I've been running my machine, the main wires, the big wires, the coloured wires that make up the pyramidal shapes in the middle, they get warm when it first starts up, but the longer I run it, the colder they get. There's no heat there eventually. I don't know.
So it's an endothermic reaction, and it's taking heat out of the environment, correct? It's cooling down the longer it's running, you say?
Yeah, the wires don't get hot after a while at all. There's no temperature to them. I've not obviously took proper readings, but just to the touch, when you first start running it, when it's slower, it's quite warm. But as the ball speeds up and it's been running a while, there's no heat in those wires. It just made me think of it when you were talking about that.
Sounds similar to like the Searle effect generator and a few other magnetic disk systems.
Yeah, we find that we can pump in a tremendous amount of current in some of these circuits, and they just don't get hot, which is really counterintuitive. I mean, you can calculate out the resistance, the effective impedance of the circuit using copper conductors or whatever conductors you're using. We've tried aluminum, we've tried um, carbon nanotubes, we've tried quite a number of different types of conductive materials in order to optimize these effects. And there's a lot farther that we can go with that. That's a Pandora's box that we opened up and realized that the conductors that you use can massively increase the gains on the system. So um, outside of that, though, yeah, these anomalous effects, you've got to pay super close attention in order to spot them. A lot of them you wouldn't even notice, or you could just write off being noise or um, a measurement error, and they'll simply go away. I'm surprised that Gerald isn't talking about more of what what you just brought up, Merkaba.
What instabilities?
Exactly, because that's entirely how your system works.
Yep, 7 different instabilities.
Hmm.
You put them all together, and they manage to dynamically multiply everything in the system. And those are the things that electrical engineers, excuse me, purposefully do their best to get rid of in a circuit or in a system itself. Like you said, noise, right? Well, when you're trying to get rid of noise in a circuit, I like using that noise. It's all part of it. Parasitic capacitance actually works to your benefit if you know how to use it, so to speak.
It's
Creates like a
interesting. It's interesting. You would think that at least somebody in the mainstream academia would put two and two together and say, we're trying to increase efficiency, but we're not utilizing any of this noise that we're creating in these systems. Like it seems like you would want to try to tag that as one of the inefficiencies in the system right away. Like how do I use this?
I blame it on years of doing things one way and that old saying, if it ain't broke, don't
Don't
fix it.
fix it. Yeah, nobody wants
Right?
to be the one that goes against the grain. Yeah.
You know what? I was hated since I was born the way I see it. So
Right.
don't
Well, like the
hey,
system is broken now,
yeah,
and we already are the ones going against the grain. So let's
exactly.
I
take it
think
all the way.
at least what
Going
drives me
against the
is
grain
the
is
seek
the
for
only way
truth.
I know how.
I hate
So
to tell you all, but you have, especially like, so I know the size of your channel, Nathan, and I know the size of your channel, Bernie, and this is the first time I'm meeting Merkaba, and I know you, Benefactor, but I don't know how big your channel is. I haven't actually gotten directly to it and subscribed yet, so shame on me. But feel free to post a link in the chat so other people can if they want to. Uh,
Sure.
anyways, known you guys for a while, kind of have an idea about how big your influence is, and then I look at the whole community. Now we've got a lot of people working on this stuff, and some of us actually have achieved success in the categories that we're talking about here. Um, we won't generally talk about it because there's a lot of baggage attached to that success. Sometimes it takes years of research just to reach the point of full understanding, and then you're kind of stuck with this conundrum of, well, do I tell everybody about what I think I've discovered, about what I believe is going on, or do I continue to research this for the next 10 years in silence and try to fully understand it before I talk about it?
you know what? I'm of the mind like this. Um, I really don't give two flying fornications what academia thinks, and I couldn't care less if it was proven one way or the other. I'm lighting lights in my house and charging batteries without moving parts, and I don't really care if there's a theory put to it or a mathematical calculation. Proofs in the pudding, and I got chocolate. So
At the end
I
of the
wanna
day, you have
share-
the results of it, right? You're benefiting
Exactly.
from it every day.
and I'm actually building multiple devices. Every day I'm finishing a new device based on these principles. And I'm going to share it all. There's no benefit it was freely given to me. I'm freely giving it. I don't care. The way that I see it, if everybody has free energy in a grid down scenario, nobody's coming for mine. I don't know if that's self-serving or not. I apologize.
I
No,
would just say
seriously.
get it out soon. You know, if you're
Yeah,
gonna get it
seriously
out,
though,
get it out
it
soon.
needs to go. Oh, I have a dead man switch on. Don't kid yourself. There's 37 people on that list, maybe more. I'll just say 37 confirmed. Anything happens to me overnight, everybody's getting. So I'm not worried about that. I'm just sort of working it one day at a time. But anybody and everybody who's working on this that gets to a level where they're seeing anomalous effects, you should have more than one dead man switch put in play. You should have a digital, you should have a physical. There's a few things that people should do to protect themselves just in case. So let me say this. I'd never in 100 million years commit suicide. Ever. It's not in my belief system. It's not in me. So I'm saying
That's
that
for me
right
too.
now. So for the record, that's it. That's all.
Right there with you. I think there's things going on in all of our projects. I don't want to release anything until I reasonably know what's going on. Like it may do the effect you want it to do, but I'm not telling you about it until I can have a firm understanding of what I'm doing and how the flow got there. Because that's the first question everybody asks, isn't it?
Right, exactly.
Absolutely.
And especially with your system, you're working with a lot higher voltages, and potentially dangerous scenarios. So, you don't really know what's
Not
going
so much high voltage. It's switching. It's changing fields.
Yeah, like I'm not saying I don't understand my system. I've written lots on my system. I just don't care if academia understands it. You know what I mean? But yeah, you're not wrong. It's better to
I
understand.
don't think academia really understands like much at all these days, so it shouldn't be the top concern, right? It's like if it works, teach others how to build it so it can work for them.
Honestly, my concern with the academia goes about this far. I try to do my research mindfully enough where I use the correct terminology in any kind of disclosure that I'm going to present. So I want to use the same terms so that we're all on the same page and academics can follow along, but whether or not they approve or disapprove of what I'm presenting, I could give one less about. So the evidence stands for itself. The devices either work or they don't. And experiment stands beyond theory. And I don't really care what anybody has to say beyond that point, but I do try to use the correct terminology because I want us to be able to at least communicate on the same plane. It's important to learn the terms. I know that academia is this big bane for a lot of people, and myself included in that, because they've got their very closed loop, closed-minded thinking paradigms, and trying to step outside those bounds, you can get tremendous pushback.
It's a
And
click. You know what I mean?
Exactly.
Like I understand, to speak their language is something that's important in order for a barrier to be broken down between the experimenter slash inventor and the academic world for understanding theory and the physics behind it. I totally understand that. I can speak the language if I chose. The issue is it's their language, and actually, I don't know what you would call. I wouldn't say purposefully, but it was built throughout time in order to separate themselves from the regular, everyday, average guy. And if that wasn't done, maybe people wouldn't be so predisposed to looking at academia like a foreign force, so to speak. And I don't think that way. Don't get me wrong.
You're not wrong about that. You're really not. I mean, that's a lot of people out there. Your home experimenters, folks like us here today. They look at these academic articles that are entirely propagated with mathematics, with no relation to reality whatsoever, and it's just these impossible figures that don't make any sense, and they've tried to use as many symbols as they possibly could because, well, it makes them look smarter. So I get that whole prospect of it, but at the same time, to learn the language, they're not okay. I'll reword this. You can use the academic principles currently available in the mainstream to prove these theories and dynamics that we're talking about. It turns out that these principles do exist and comply with many conventional theories, especially the big ones like general relativity, Lorentz transform, quantum electrodynamics, and others that we could get into. But you can fit what we're working on into these already recognized academic principles. Even if they're not recognized by the academics themselves, it's because they don't understand the text they are reading. If you understand it better than they do, which is not particularly hard to do, you just simply read through it and say, well, I've got a real world visualization of what this looks like, and I can derive these other principles that are part of this equation from that visualization. If you can visualize in your mind, and you've got a huge advantage, and you can see these effects happening in real time in your mind. So this is one of the things that the group of us like to do is get together and we sort of co-visualize some of these phenomena and then discuss the implications of how these effects interact, cross field interactions, wave interferometry, scalar and Hertzian potentials.
Hey guys, real quick before we go any further, Makaba is going to take off. He's much later than we are. It's like 8 hours ahead of us.
Oh wow!
So
So-
sorry, Merkaba. Amazing
Yeah.
work. I had to say that. Thank you very much for sharing.
Thanks,
Yeah,
Gerald.
thank you.
Thank you
Completely
to all of
agree.
you.
Amazing research.
Yeah, I'll be
Development.
back. I'm definitely coming back to one of these. I've
look
enjoyed
forward
listening
to
to
it.
you all.
Yeah.
I'll put
The
you on
more the
the
merrier.
I'll put you on the list, Ben, to give you an invite for every one of them.
Brilliant.
Thank
Thanks
you
very
so
much
much
for your
for coming,
time,
man.
guys.
Yeah, thank you very much.
Thank you.
Catch you later. Bye now.
Bye. I'm probably not going to stay on too much longer myself. I got to finish up that Divine Science editing. Almost done. Got to finish that up tonight.
Yeah, I mean, too. I have to jet too. I was gonna say,
Boo!
I agree with you, Jeremiah, but I like what Nathan does. He likes to fry it and find out. I love that
I got
saying.
no
I really
problem
do.
with trying it. The new circuit that I'm putting together with the 6-phase sequencer is all 3 terminal blocks for each individual MOSFET. So when they do blow, which hopefully I blow a couple of them, because I'm going to push it to that max power level, then they're easy to swap.
Do you guys, or Nathan, do you mind quickly just playing the Merkba video of the design of his for my channel? As we're also, I went live on my channel, but I've yet to cover his generator, where you've actually gone quite extensive into it the last few episodes on your channel and on these think tanks, and it is something else.
Yeah, I'll put it up right now for you.
Thank you, sir.
Matter of fact, we can play a couple of them if you want.
Oh, this is cool.
Right, and just so many of us making our own designs and coming up with anomalous breakthrough results.
I know.
That's one of the coolest thing I've seen when I saw it.
Where did you find this, Nathan? Just on YouTube?
To be honest with you, man, I was on Facebook and he contacted me.
Oh.
And we got talking back and forth, and he showed me this, and I was just in awe. And I'm like, okay, everybody's got to see this.
Yeah, this is definitely unique. It's definitely unique.
Oh, I should have asked. How are you doing the frequency sweep on that?
That's fast.
So he doesn't have a motor spinning that. It's like magnets and coils that are causing the spin. Is that correct?
So
Those
hold on.
orange coils and those green coils are causing the rotation.
Wow. That's wild.
And he's putting an amplifier into it. It goes into the little coils around it, and it's making frequency inside.
So no actual motor, physical
Nope.
mechanical motor going in. That's all rotation from coil fields, electromagnetic fields
That's
causing
right.
rotation.
Yeah, in crypto, you'll love this. He uses ancient history as the design for this stuff. So
That's awesome.
when you look at his work, he's looking at flow works, you know what I mean, in ancient symbols and stuff like that, and all that kind of work.
Yep.
And I can show you that in a little bit.
Wow.
But
Yes,
that's where he's
please.
getting his designs from, the triangles and the, you know, I mean, different shapes. He shows a shape earlier in the video of what he's actually doing. It's Makaba, is what he says.
I love how he has a ferrite magnet on the bottom, but it's so far away from the actual spherical magnet. There's no way it could affect it unless that Merkaba design's actually doing something.
Right. Exactly.
So here, I'll show some more of his stuff so you guys understand.
Please do. This is wild. And yeah, the sacred geometry, it's designs, it's two-dimensional blueprints of 3D things, right?
Yeah, this ties in kind of to Bob Grainier's research.
Yeah, so this one right here, he's going to tell you how fast this thing was going. Top speed. Now he says that every one of the frequencies you have to put in one at a time on the coils in order for it to work. So each one of them is doing something different to the magnet in the center. I would have loved it if you could put a little ball on it, a little line on there, excuse me, a little line just to show where it's at. I don't know if you see it that speed though. So in this one, he's using copper ball inside of that little piece right there, the big piece of plastic in there, and I'll turn it back on.
A lot of the
Here.
thunder.
Sorry.
A little bit, let's say, looking in there earlier, but I think it's probably gone now. But when we bring it close to the spinning magnet, feeling a lot of the thunder. The magnet's slowing while the copper ball's increasing.
Okay, I'll pull up another one. Oops, sorry. Still not as good as you are at this, Bernie. So I'll figure it out.
Sorry, I've got to run, but
You're learning,
it
right?
was a pleasure.
Oh, Jeremiah, I needed to talk to you, but fine. Savage.
Oh yeah, you know how I am.
All right, Jeremiah, thank you for showing up, man. It was really cool. You guys did stuff on the early part of the show with
Love you,
the
Jake.
yeah, with all the Mercury was awesome.
You know, we love to do the experiments, right? That's who we are. We are a community. When we try to support each other, and when there's an interesting topic like this one with rotating Mercury and gravitational effects or electromotive forces, we've simply got to investigate it. You know, it's
100%.
practically an enigmatic compulsion. We have to do it.
I'll have to review that. I only caught the back end of it, and that's awesome you came on.
So I will catch everyone later, but thank you so much for the great show, Nathan.
Right
And
on. Thank you.
Yeah,
you
thank you,
guys
Exotic.
catch it easy, and hopefully, I'll see your future shows and determine based on the title if I'm gonna join. So I'll see you then.
Yeah,
Take
we
it
All
hope
right,
easy.
to
man.
see you. Bye.
Much love, Jeremiah.
All right, so let me pull up another one here for you guys.
Just
I'll just pull up his channel here in a minute. He does the Mercury experiment, but he also, I'll show it to you right now. So look real quick at the ends of the Mercury and look at the divot inside those right now. It's actually pulling in and sucking in like a vortex. So you can see it on the right and left side of it.
That's interesting.
So they definitely got some way cool experiments. So, all right, guys, go ahead and talk for a minute. I'm gonna pull up his channel again and get this thing going. Hello.
I was just stepping out for a cigarette for a moment and then coming back. I was like, play the video so I can step out for a smoke. Then I promise
Oh,
I've got lots to discuss as soon as I'm done.
oh man, right on.
It was a quick video, Bernie. That's all.
Yeah, sorry about that.
Well, shoot.
It looks like Ben just disappeared. Maybe while running that Mercury, it was like poof. I'm kidding. I'm kidding. I kind of
So,
wonder though, if you had a Mercury chamber in the middle of that Merkaba, but it was like it was shaped differently, kind of like a tube in a tube, and the inner tube would be shorter than the outer tube, so that the Mercury could climb up the center tube, fall into the outer tube, and then come up from underneath and climb back up again. Kind of like a magnetic field line excursion. I don't know, just a thought. I wish I had enough Mercury to try it.
yeah, me too. Yeah, this one he changed the center out, and he's actually got it going inside of this little piece of 3D printed material here, and he's pulling. I would imagine the lights are connected to it, and it shows it lighting up as he goes.
Wow, I don't think I've seen this one.
Remember, he was talking about the different types of LEDs as well.
Yeah, because they light at different voltages and at different currents.
Yeah, it's just so cool.
Yeah, I guess that's solid state. That's kind of like what I've been doing. That's awesome.
Yeah, well, he still got. I think he's still got the magnet in the center, but it's producing the field, and you start to see it. I kind of wonder what would happen if you put the Tesla meter in there, and just to see how much Tesla force is in there between the actual outside frame and the rotating magnet, because you're getting two different fields
Yeah, but is he rotating the magnet right now?
inside the little piece of.
Oh, he is. He is.
Yeah.
Okay, so it's on mute or something then.
Oh yeah, I put it on mute. I'm sorry. I'll
No,
play it again.
that makes sense though.
It gets loud. There you go.
Right. Okay, that's fair. Now that makes sense why the bulbs are lighting up. He's capturing that back EMF
Yeah,
from the actual spin. That's pretty cool.
dude, that whole design, just the way it looks, is cool.
You're
So
not wrong.
he's got a new one. Okay.
Something
So
different?
he built a second one. So let me pull up his work. He shows it. Let me share the screen on this right quick.
Awesome.
Uh, so I need to remove some stuff. It'll take me just a second. Share the screen. So this is his new machine here. Let me start it over.
Wow, look at that. He put some love into that.
Yeah, he did. I think he's got a lot more hiding under there. I'd love to see it because he's talked about the coils being set up. So
Interesting.
yeah, this guy's channel's all interesting.
Yeah, I want to see what that thing's going to produce. I just started looking at his work, but it's based on the same principles.
Yeah, you just don't have the rotating magnet in the center. All the other types of things, field upon field, is all kind of in there.
Yep.
You might have to get with him, Gerald. He asked to talk to you. So I sent him your channel. I'm going to send him your email if that's okay.
Yes, by all means.
He wanted to talk to you about some of the stuff going on here because I'm sure your work is going to cross over with his. Very good.
Yeah, I imagine it will. Looking at his system and seeing how it works, I imagine it'll cross over quite a bit.
Yeah, you'll have to teach him how to capture in those little spikes every time captured in that capacitor.
Absolutely. I already have a good idea on what I could do with his system right now. I've already took it apart in my head and put it back together twice.
Oh man.
Yeah, it's something that I've done since I was a kid. Maybe it's a really good imagination. Maybe it's, I don't know, but I can see it perfectly in my mind exactly how to improve what he's doing. What he's doing is already awesome.
Yeah. He's ahead of me, and you're ahead of me on all that. I haven't worked on that stuff in a while, man.
Yeah, but you're ahead of me on high voltage, so you win.
Oh. I don't know that I win.
No, I'm seriously kidding, but you know what I mean.
I win
We
the
all
booty
have our own
prize of getting shocked a lot.
Yeah, I've gotten shocked a lot too. Not so much with as much high voltage as you, but yeah,
Oh
definitely.
my god. I think I see it in my dreams where it shocks me.
You definitely feel it in your sleep, right?
Oh my god,
Your
too.
body's aching and
You know, my arthritis in my hands keeps getting worse, and I'm thinking it's from that high voltage getting shocked every few days.
yeah, that might be it. Little inflammation there
Yeah.
bursts.
The exact opposite from Dr. Ho's shock therapy.
Yeah.
It is the opposite. It has the opposite effect in my body. I can tell you that.
Yeah.
I need Gerald's coil to heal my hands again.
I agree. I totally agree. Need to pull that extra energy out that you put in by getting zapped.
That's right. Let it pull some of it. Yeah.
Yeah.
Hey, check this out, Crypto. You back from smoking? Nope.
No.
Yes, I am. I'm here.
Hey, check it out. I wanted to show you this because, you know, I know you're all into this stuff. So check it out. This is where his inspiration comes from.
Oh, yeah.
So he's saying the energy swirls and it makes this pattern in there. And the swastika is just the energy flowing in that pattern.
The representation of it. I've
Yeah,
seen
vortex.
several times with that.
You know, I'd have to agree with them because I don't want to give away certain things that are in my coil. But when you, I'll say this: when you take a form of a triangle and you spin it, you can see that swastika in the form when you're building your coil.
That's insane.
It's very
That's an ancient symbol. Yeah, that predates. Just for anybody watching who isn't aware, this predates the Nazis taking the symbol and adapting it. This is very ancient symbol. It goes back to Buddhism and other ancient religions.
Thousands of years, right?
Yeah, it wasn't always.
This would explain why they still have it carved in so many of the different temples across Asia and India and whatnot, is because it's representing the energy of it.
Yeah, they clearly knew something we don't.
it was part of their power system. And I believe 12,500 years ago, maybe even 13,000, before the flood, I believe that they had this tech. I think that they had free lighting. I think that they had motors, electrostatics. I think they had mastered this electricity. And then after the flood, it's like starting over again, right?
So here he's trying to visualize how it goes in, and he first came up with this one right here, where he thought the magnetic field was just spinning like this, right?
Mhm.
So, but a magnetic field never spins like that. It always spins in spheres, right?
Right.
But on the opposite side, it pulls in the energy. And what he was saying is the energy pulled in is like this. It makes that Makaba shape.
Wow.
And I wish I can go back and show you the live. I'm not sure. Oh, there's the shape right there, or kind of close to it,
Mhm.
where he has the different triangles in it. I'm trying to find it real quick.
That's wild. How it just sucks in those particles.
Yeah. Let me see what he's got. Oh, so it's a different one. But he was saying like the spin and the different triangles and stuff like that. And this is a representation. If you put it in 3D, it's more like the, I want to say Israeli or their symbol. You know what I mean? That star.
A Star of David,
The
right?
Star of David,
Yeah.
yeah.
That's what his Makaba looks like. So I'm trying to find, if you see it in 3D, it's a lot different than seeing it in 2D like this. So trying to see
Yeah,
if you had it.
the Star of David's like the 2D version of an actual Merkaba, and what magnetic or Merkaba magneticity. I'll say it eventually properly. What he built is an actual Merkaba.
Now, I'm very impressed with this whole setup. It's very unique. It's something that I didn't think would be even possible, but I mean, clearly it is. Just with, but I mean, I haven't really researched triangle power yet. You know, pyramid power. It's something that I haven't really delved into, but hey, this is really cool.
I hate to break it to you, Ben,
There's a
but
lot.
you're holding on to I wouldn't say a weaker version. You're holding on to a different version of the heart of a pyramid. That's what all this vortex tech is literally the core heart of a pyramid. If you go 1/3 down on the inside apex of a pyramid, there's a cluster of charge density that forms in every pyramid just due to the very shape and the
Does this
movement of the earth itself.
does this have anything to do with the hourglass shape that is the inside of
Similar,
Taurus?
the
Similar.
hourglass shape is a form of a pinch, right?
Right.
Well, the heart of a pyramid is the form of a pinch as well. It's actually the bottom half of the circumference of the pinch. And if you go up through the apex of the pyramid and were to take the exact same size pyramid, flip it upside down, and go point to point, you now have the identical circumference of that energy heart of a pyramid and the apex above it in that secondary pyramid. So between two pyramids, from point to point, one facing down, one facing up, you get a pinch in the middle of those two pyramids in that point. And then the vortex shows up on the inside apex of both. And that's what the hourglass kind of means. So the Merkaba is like a compression of both, almost the form of a portal, or you could almost consider it a wormhole in a sense, because it compresses both into one solid sphere, or ball lightning, or call it what you will. That's my theory anyway. If I'm correct, I don't know.
Well,
we'll see.
I know one thing's for sure, and that is that I'm definitely gonna have to consult with you when I do my episode on Joe Parr.
Sure. Nathan has a lot of information on pyramids as well.
Yeah.
Yeah,
So
definitely
yeah,
do.
it's not going to be anytime soon, but definitely have to consult with you guys on pyramids, because I don't know jack about pyramid power or anything in that regards to what Joe Parr was doing with the shape of the pyramid.
Well, there's more to it than that. Even Nathan was, he even clued me to a piece that I was missing. So it's everybody has their piece of the puzzle. And I think if we come together and we all express it, we're going to find how it all comes together.
We're going to find Waldo, finally. We're going to finally find Waldo.
It's like if you take a piece of quartz and you turn it the correct way and you take a big neodymium magnet, you'll feel the force. It feels like eddy current when you put it close to rotating magnets. It'll actually have a force that pushes against it.
Absolutely.
So a lot of people don't know that. They just think quartz, whatever. And I keep telling people, you got to activate the quartz. You have to be able to take the oxygen in there and take all of the streams in there of the oxygen and be able to magnetize them against a magnet. Then you're going to start to get a force, because think about it then. If you're getting a force of eddy current inside your piezo, if you simply can put that side close to it and then rotate the magnet, what are you going to get then? Are you going to get the piezo to light up? Is it, you know what I mean? Is that piece of quartz going to do something special for you? If you simply took a piezo disc and attach it to a piece of quartz on one side, can you get that pulse rate to push in there and get you to get it to light up? There's just a lot of different things about quartz you should think about. And then you also have to think of how you're going to pull the energy out, because you can spark two things together, but that's not going to give you the energy. You actually have to put it in salt water or some kind of water with fluoride in it in order to pull the energy out, because you want to put the wires in the bowl of water with the fluoride in there mixed. And in California, they put fluoride in the water, so it doesn't really matter. But what I'm saying is every time you tap it, you're going to get an energy that pulses out. You can't just pulse it through the quartz. You have to find a medium to pulse it through. That's what the Egyptians knew, and we didn't.
So
Absolutely.
the salt water or the water acts like a conductor for
Yes,
the
so
electricity to flow out. Yeah.
fluoride is in rainwater. So when you have around the base of the pyramids, you have this valley that's all the way around it, and it's held in by a little wall. Okay, when you have rainwater in there, or you take the Sphinx right there and you fill it up with water in that little pool thing they have sitting there around it, and it goes and flows over to that other area, it'll always keep it filled with that fluoride water in there. And then actual quartz, excuse me, not the quartz, the granite will pull it up inside the pyramid. It acts like a candle wick. So
Yep.
it'll actually keep the entire thing soaked in water. Just like we have water in the center of our earth that's held in there in rock, it does the same thing.
Yeah, it's hydrophilic. That was the thing that you clued me into that I wasn't fully up on. That's awesome.
That's crazy.
Yeah. We could probably set up a clear box and then basically just take a heating coil and take a piece of granite, put some part of it in water. We could suck up all of the water into it, heat it, and then it'll come up as vapor and then come back down. It looks like kind of rain on the sides. And we could keep just a whole thing rotating with changing from water to, heat to, what I mean? Everything else.
I do. Yeah. Evaporation, condensation, all that. That's an interesting experiment.
I'd love to put a ring of high voltage around the top just to see if I can get a cloud to form.
I started building a
guaranteed
real
it will.
life pyramid that's 3 feet tall. I haven't finished it yet, and it's on the back burner right now. I had announced it on Ashton Forbes' channel. I actually got the recipe for building the brick that's the original formulation for the pyramids themselves out of the Geopolymer Foundation, and I tested it, and it's the actual stuff, and it is hydrophilic, just like granite. So I started building bricks, and I got it about 1/3 done, and I built the other bricks, and I just have to continue to put it together and shave the bricks down and make it like pyramid shape. But when I get that done, I'd love to do what you said, get a bunch of plexiglass and maybe encase it in plexiglass and then try that experiment. I kind of wonder. That's really You got me thinking.
Absolutely. The plexiglass would add a static shield or field around it, no?
Yeah, well, it
See?
would.
That's why I
Yeah.
want to see if it gets into a cloud.
Yeah, see, you got me thinking again, Nathan. See, we all have our talents. Yours is high voltage. I love it. Okay, yeah, we'll have to get that done eventually.
Hey, Bernie, what were you showing a minute ago? What was that?
So this guy here, I kind of destroyed it at Jeremiah's request because he wanted to see how it was built, but I need to rewrap it. It's a tetrahedron pyramid of just copper wire and aluminum foil that when I had it made properly, anyone that, well, not anyone, the majority of people that would hold it in their palm, you instantly feel heat being formed underneath it, to the point that lots of people like felt like they were being burnt and had to drop it. And then what was very interesting is that anyone that was intoxicated on alcohol or anything, just no effect at all, as if it wouldn't create that energy or collect the energy that it used to create the heat.
Just with the geometry alone, yeah.
Yeah,
Shape
of
power.
just like copper wires in there in triangular fashion on how
I'm sure
it's,
touching your body creates some kind of closed circuit of some kind, but what?
or open
what?
circuit
Or-
that's then collecting energy out of the static field or
Right,
heat
right.
from the environment.
Right,
Well, I
no, that
think
is probably more accurate.
I think alcohol. Sorry, let me remove this real quick.
There
I
you
think
go.
alcohol pulls in all of your blood to the center of your body and tries to burn off the alcohol in your body. So you wouldn't get the same feeling you would. It's like sitting in a bunch of cold water. Your body automatically pulls everything from your extremities and pulls it inward.
Huh.
So that's probably why you couldn't feel it when you're on alcohol and why you get in accidents and you don't know that you broke your arm. But the fact that it actually makes your hand hot when normal condition is just totally amazing. Sorry.
Right? No worries.
Still trying to get
You
used
may
to
go. Oh, you're learning. You're doing good.
it.
Yeah,
right.
Ben, have you any new developments with your PoE coil?
Not entirely. I haven't really had time to work on phase 2, but we have decided we are going with the Bedini circuit. If you or anybody you know has I think we're looking for a 24-volt battery that's completely used up, maybe like 3 volts coming out of it. We need one for phase 2 testing. Like I can buy a new one, but I have to shop around for a used one that's, gonna be able to serve as a good experiment. See if we can rejuvenate it.
I've got a version of Bedini circuit you're going to want to try after you try your version, because it does something just a little bit different than what Bedini was doing.
For sure.
And I used it. Yeah, and it allows you to gather power real fast, slam it into a cap bank, and use it as a ground or as a load.
But to just extend on what I was saying there, Crypto, lately I've been in crunch mode trying to get this video out, and it will be out Saturday at 8 p.m. So I'll send you all an invite to the premiere and all that. It's going to be really great. It's going to be about an hour long. It's going to be on time travel. So, but once that's out, it's all phase 2, baby. So.
Well, I'm going to time travel ahead and go watch it.
Come back and tell us how it was.
It's good. It's good. I don't want to spoil anything, but I think I've reached the height of my production quality abilities. You see, like on my previous videos, I was kind of like,
awesome.
80% there, 90% there. But well, I like as a self-critic, I have to be realistic. But I think I really nailed it with this one, so I think you guys are going to enjoy it.
I call it the Spider-Man principle. With great power comes great responsibility. It's true.
For sure.
All right, guys, you know what? I hate to bail on you, but I'm getting a stink eye. I got to go make supper and all that family jazz. So thank you for having on, Nathan. It's been a great conversation. Hopefully we can do this again.
Thank you,
Yeah.
Gerald.
Thanks, Gerald.
See you guys
Much love, Gerald.
later, Bernie.
Here's a picture of an ice cube with the colloidal gold silver water that I make. And you can see the exclusion zones and the fields of bubbles that it produces there.
Speaking
And
of the activated, I'm sorry. Go ahead.
That there's I've got many of these ice cubes that's like just.
So there's no coil in there; it's just the air bubbles.
Yeah, you got it.
Speaking of
It's
the
just how
activated
it
water,
freezes.
you gotta email me your recipe. How do you make that activated water that you drink?
I just make monoatomic gold out of pure gold anode, pure gold cathode, and salt water, and then collect the monatomic material at the base of it.
Do you have like a video where you show the process or anything written down? Okay.
Many
Yeah,
videos.
just when you get time, send me a couple of links of some videos of you going through the process, and because I'd like to make my own for sure.
Absolutely. And then from there, you just rinse it out a whole bunch to get the salt out. And after about 9 rinses, then I start using the colloidal water at the top there that absorbs the monoatomics as that water that you saw that froze into that ice cube there. And then I'm testing the plants with and some of the water that I drink with.
What do you mean testing the plants with? You're using it on the plants?
Yes, absolutely. I'm doing agricultural alchemy experiments with these jars of water here, some of the purple and silver gold, as well as using the white monoatomic and trying some of the blue oxidized diatomic. And as I suspected, the blue and turquoise diatomic oxidized water actually harms the plants, stunts them, and poisons them, where the white and the purple monoatomic water exponentially increase the growth rate of the plants.
So white and purple does good and the rest kills them?
So white and purple are good, and then I suspect the yellow, the blue, the green are the bad ones.
I remember you mentioning the blue one on stream was toxic. You wouldn't drink it.
Yeah.
Would that be like something you could accidentally make during the
process? Oh yeah, it does start. So when you start the reaction, it produces the white monatomic to begin with, and then about an hour or two into the reaction, then it starts oxidizing off. And after that, it goes into the other 6 colored states of transmutations of elements that Isaac Newton talks about.
That's crazy.
Hey, Bernie, there was a question here for you.
Here's some more pictures of different ice cubes with these fields. Oops, wrong one.
Oh, that's cool.
Yeah, you can see it. Wow. You can see the wave. It's literally a waveform.
Exactly.
Wow. You've captured the effing frequency.
Wow. That's really cool.
Yeah, that's insane. I mean, I'm sure it's magnified because of the ice and all that stuff, but sure, like that's a slice of time right there. That's crazy.
Yeah, that's like
it does it to all of the ice cubes with this water.
Wow. And that's a sign that you did it right. That waveform.
Right?
Okay, so that's going to be the marker that I'm looking for if I make this activated water.
Huh.
That one almost looks like a vortex, doesn't it?
Oh yeah, and often when I mix the fresh water in with the monatomic in salt water as I'm rinsing it, it will create these vortexes and spiral looking galaxies with exclusion zones of like arms of the monoatomics, then just straight water, then the monatomics, then the water. I'll get a
That's
couple
really
pictures
cool.
of those up to show you. And so here you can see the whole ice tray.
Wow. Yeah, you can see all of them. All the waveforms in the top. And they all look relatively about the same wavelength. Am I wrong about that, or
No,
is
you're
that,
correct with that.
huh? It has to be like a slice of what's happening, in time. That's really cool. Like a dinosaur frozen in a cube.
Yes, sorry. Give me a moment to find the other pictures if you want to put it back. So to make it, Nathan, to make it go back to the way you had it with all four, I believe it's either to the right of all of the pictures of us or right below on like the main part of the screen there of,
That
there you
one?
go. You figured it.
Okay, got it.
You got it.
Getting better.
Exactly. It's just a learning process.
There was a question for you, Bernie. I'll ask it for you. Okay. So have you used distilled water and gold yet? So you know that you're getting actual gold and not cascade of minerals.
Yes. Right here, for all of the ones that are just like straight first time experiments, I have the distilled water and use distilled water, and that, let's see, distilled water, right? And that I found no difference in distilled water or my Canadian tap water, but anytime that I'm running it as a straight scientific experiment, I use the distilled instead of the tap water. And it's that the monoatomics I'm making is not from a chemical reaction like most Ormus practices where it's taking it out of the water. What I'm doing is I'm using electrolysis where the material being formed comes straight off of the physical metal solid anode that's in that reaction. So when I'm claiming that I'm making monoatomic gold, it's off of a 24 karat gold anode and 24 karat gold cathode. The silver, it's, I use a 99.999% silver maple as both the anodes and cathodes. Copper, it's copper. Zinc sort of thing, right? So that there's no possible way that it's other elements in what I'm making.
But also, if it's using the transmutation process, which is what we know is, charged clusters, if it's transmutating anything in any way, then it is relevant what's in the water.
Oh, absolutely, yes. And that's another part of the experiments and the process and the theory and what I'm doing and more advanced aspects of it. But this is just strictly for the Ormus monoatomic material and how to make it.
So would you recommend the distilled water for drinking, or it just really doesn't matter as long as you get the waveform?
Yeah, I would go start with distilled for sure. Then you know everything that's going in it, and that's actually especially true in areas where your water like might have like poisons or heavy metals and stuff like that already in it. 100%, because then you don't want to be charging those particles and those other heavy metals that are in that water into this Ormus state.
That makes
So
sense.
what does this stuff do when you drink it? Just
I've been
hearing about it.
I've been drinking it for 10 years now. I never caught COVID, never got no shots, was exposed to it like over 50 times at least. I haven't really been sick in 10 years. And people saying I'm looking pretty young still, being 39. I don't know, maybe it's delayed me at 28 or 29 since I started drinking it.
Nice.
Hopefully, we'll see.
He found an elixir of life.
Potentially, right?
Cousin. Yeah, that's crazy.
We have some truly remarkable people in this group, on these shows, like some really crazy stuff's going on.
With my agricultural alchemy last year, I put some of the actual monoatomic gold here next to a lettuce plant, and it grew 6 feet tall. And then all of the plants, so this is the purple gold and silver
Do you
combination
drink
that
the
I made
purple
here.
too?
Yeah, I've been drinking the purple water now for 2 years, and it's completely fine. And it turns purple when I leave it out in the sun and the moon. The sun for the gold, and the moon for the silver,
Huh.
for those reactions. Or if I put some of my own, like saliva, blood, hair, like DNA
Biology. Yeah.
biomass into the reaction as well, then sometimes it also forms it into purple state.
That's
But yeah, so
crazy.
watering with the colloidal water, the plants grew like 3 times the size of the other vegetables that were just with regular water. And then when I actually put some of the physical gold silver ormus next to it, it was double that at 6 feet tall.
Dude, imagine growing some crops with that water and my coil.
Right? Exactly.
Wow.
That's the goal of it.
So interesting. Man, I learned more here than I ever did in school. That's for sure.
Right? I think
Yeah.
everybody does, including myself. It's that right. It's sharing our own knowledge and what we've learned from it, and
They tried to
not
keep telling me how to build an essay. Man, I could have been so much further ahead if they were just teaching coils and wires and, you know,
Right?
stuff like that. We can, learn how to break stuff apart. Man, that's the fun of it.
exactly. And yeah, so I just got confirmed on Sunday. This Sunday evening, I'm going to be doing a stream interview with Kevin Hay, and he does Vancouver Island Ormus, and he's just brilliant genius, and he's been showing results of like 3x, 6x times plant growth with all of his Ormus that he's been making for over a decade now, and also goes into explaining free energy, the ether, and just so much more.
Hey,
Well,
Bernie,
I'm
did you
excited.
post the time of the stream and everything in the chat?
We are yet to figure out the specific time, but I think it'll be probably around 7 p.m. Pacific, 10 p.m. Eastern.
Okay. Gotcha. I'm still awake at that time. We're good.
Right? Exactly.
I'm in California, so when sometimes it's like, wow, it's like 9, 10 o'clock. I got up at 2 in the morning, so it's like, wow, like way far out of my range.
Fair. Yeah, I'm working on being on more reasonable time zones. Usually it's like I'm nocturnal by nature, and at 3 a.m. I get inspired to finally do a stream,
Oh,
or it's like
I
I
noticed.
start putting it together at like 2 in the afternoon, and then it takes like 10 hours just to get all the freaking information together.
Dude, I think last week I woke up at like 4 in the morning and I missed your stream because it was like 2 hours earlier. And I'm
Right?
thinking, man, just a little bit earlier, I could have caught it.
Yeah, and that's something else. I'm like, instead of starting in the middle of the night, just wait a couple more hours to like the morning, and then y'all be able to join in.
Oh, man.
Well, we really
Yeah.
enjoy your streams. I know your last one was really good.
Appreciate that.
Yeah, I
what
love
else?
the breakdown in metals, by the way. I was checking that out as you're using the electrolysis, and everything comes, completely destructs this whole thing, man, into nothing. It was just awesome.
Yeah,
I
and
was,
so the next experiments that I'm gonna try, I've got a bunch of extra microwaves. I just don't want to do it around my house. I got to get like extension cords and a big field somewhere. But apparently, when you put the monatomics in with microwaves, it actually puts it back in a solid state, and that there's been many stories of it also transmutating them into new elements of, if you're combining different elements of Ormus together, that it'll combine them into heavier, like the adding the two together, sort of thing. The
Well,
atomic masses and giving you the new mass of whatever element that is.
if you cut a hole in the back of your microwave and attach a cell phone to it, you can get the camera to go right inside there as you're doing your process. And then it actually keeps the chamber intact. So you're going to get the microwaves inside of it. And you can get a spectrum analyzer in there, anything like that. It'll actually show the different temperatures and what's going on in there as well. So just so
Really?
you know, for your experiment, when you get an old microwave, keep it. And if it works, cut that little hole in the back. I'll send you a video on it. There's a young kid. I say he's young. He's probably about 25 now. He does this experiment where he lights up aluminum foil with a little beaker over top of it, and he creates plasma in the top chamber of it.
Really? Okay.
Yeah. You know what? I'll look that up while you guys talk. Let's see if I can't show it real quick.
I like the sounds of that.
But the way he sets up the experiment is perfect for you, what you're doing.
Right? Oh, big time. And especially apparently there is a like I can never say the freaking word. Not even gonna try. Whatever it is, the analyzer of the light waves of what elements are, app program for smartphones. Mass spectrometer. There we go. Right?
Oh, check it out. Okay, I found it. All right. Hold on. It's playing with me just a little bit. All right. So let's share the screen. Oh, that's the wrong one. That's the right one. Okay. So, yeah. Hold on. You can see he looks like a kid, right? Like I said, he's probably much older than that by now. Let me see if I can't find the spot where he does it. So you see the little pinhole in the microwave there in the back, right,
Oh, yeah.
right in the center of it.
Yep.
That's where his camera's coming through. So
Right.
check out.
Just need to make it large enough. See, that's ingenious.
So watch as he shuts this thing. This is what it captures on the inside. So watch this. It'll once he rotates it, man, starts it up.
Wow, I think I've seen one of these videos and I didn't know it was.
Yeah.
That's how they capture it. Yeah. That makes sense now. Yeah, I've seen a few of these and I was never wondered how they recorded it.
Right, yeah. Like, how did it.
Now it all makes sense.
It
Everybody
does.
lighting stuff up in the microwave, yeah.
Yeah, like, how did they do that? I never stopped to think, how did they do that?
I did.
I
always
know,
stop and
because
think, hold on.
you operate on a different level, Nathan.
Look at that. Oh, look
Oh,
at the plasma,
wow.
man.
Right?
It's
That's
dancing.
wild.
It's dancing. Yeah, that's crazy.
Aluminum is my favorite when he hits that. So when he does aluminum foil in there, he said he did like silverware and it really didn't do much. So
Huh.
Dude, he
kind of
must piss
strange.
off his parents a lot.
He's sitting in his garage with like 50 different microwaves.
It's all smelling like burnt plastic and
Burnt metal.
burnt metal, yeah.
So which one's this? Oh,
That's
it's
still a
matches
match.
again? Huh.
So hold on. He's got the matches. Let me find. Oh, now he's just lighting stuff on fire. Okay. There it is.
Oh, there's the tinfoil.
Yeah, look at that.
It's just beautiful, isn't it?
It
It's
truly
blue.
is wild color, right? The blue of it,
And then there's purple flames at the bottom. Did you see
right?
that?
White light, blue outside, and what?
Well, you don't see them now, but at the start of it,
I
you saw
saw it.
some. Oh, there you go. Wow.
Right. Purple at the bottom.
Yeah, you see the plasma start, and then he uses an analyzer to check out and see what light spectrums he's getting. This is like,
That's next level. See, that's what I need to figure out and start doing.
so he tells you how he does the trick, by the way, for the microwave in the video. So as soon as the video's over, I'll go ahead and post it in the chat for everybody. But,
Appreciate that, Nathan.
yeah, this guy, you see his experiments, man, and they're just off the chart. So,
Yeah, I need a real lab. There's just only so much I'm willing to do within, your own home and property. And
Yeah.
oh, look at that. He just melted that.
this,
Yeah,
that was
there's a lot of
glass? No,
experiment-
that's gotta be plastic.
That was plastic.
Okay.
He was showing you different materials he put it in.
Gotcha.
It's crazy how
So we
it
can't-
forces the ball to the top, or it forces it to the top into like a little plasma ball.
Yeah. Oh, yeah. It's same thing happens if you put grapes in a microwave and capture it like that.
What's in the
Yeah.
grape that makes it do that, though?
What's in the grapes? I
Certain
don't know.
chemicals, I guess. Certain metal elements, I'd guess then.
I can look it up. Let me see.
Yeah. That's interesting, because I forgot about that little factoid, putting grapes in there.
Yes, I believe blue shift to red shift, that's space-time distortion, correct? Yeah, I think so. That was a question. Pretty sure.
Oh, here we go. This one looks like it lit up. So let me share that. Let's see what this guy's doing. What has he got? He's got grapes. Yeah, yada yada. Let's get on to the grape.
Right? Like, just how much do we need to? How much of a video can you make about grapes in a microwave with plasma without it being the grapes in a microwave with plasma?
Exactly. All right, now we got some grapes.
Wow. Look at that. That's crazy.
But the reaction's even wilder when you cut the grapes in half. It doesn't look like they do that either.
Yeah, I don't know if he's going to do that. It's kind of pushing it.
There we
it
go.
goes.
There we go.
Oh wow. Wow. The grapes like fused themselves together. Look at that. That's insane.
But then when you put the glass over top, it shoots the plasma up and catches it at the top and does the same as like the metals were.
Oh.
Yeah, there it goes right there. I think he has it in glass.
Yeah.
That's crazy.
You gotta love plasma, man. All right. This guy took forever to get to things. Sorry, I
I
don't
guess
know about
he's
you.
actually explaining some science in there. We're just not listening to it.
Yeah. We all just wanted to see the grapes. Come on.
Well,
Exactly.
Gotta
And
get-
plasma.
Got to give him a little grapes in the beginning to show it kind of doing what it's going to do. Then you can watch the science.
it's about time for me to hit that old dusty trail, gentlemen.
Yeah, me as well. I got my mom's waiting on me to come help her with some gardening stuff, and well, it's the hottest part of the day is now over, and I got to get my butt down there before the sun sets. But I will be back on, I believe, with the Woo Woo Wednesday episode in a few hours with Hans Dietrich. The Sunday with Kevin Hay going over the Ormus. And then August 8th, I just confirmed my next stream with Walter Bosley. And there's, oh my gosh, and I need to email Randall Carlson, as I think I actually got a stream coming up with Randall Carlson and the Medicine Hat Badland
Could I
Guardians.
please come on there with you
Nice.
when you have Randall Carlson?
Not the first time, but
Ah.
definitely down the road.
Okay, fair enough.
Hey, that's awesome, man. Awesome.
Much love, guys. Thank you for what you guys are doing, and we'll see you again, probably if not sooner, but Friday night, free energy Fridays, and be back. Hopefully, try to make your Monday stream as well. And much
Thank
love,
you.
my friends.
Have a good
All right,
one,
guys.
Bernie.
Have a great night. Thank you for the great stream, everyone.
Have a good night, Nathan. Thank you. I really
You
appreciate
too. Thank
it.
you. See you later, everybody.
All right, that was an amazing stream. Before I end here, I'm going to show you guys the trailer to an upcoming episode of Divine Science, a very special episode coming this Saturday at 8 Eastern Standard Time. Give me 1 second and I'll pull it up.
Imagine a world where time travel is no longer confined to the realms of science fiction.
Time travel. It's possible, sir.
Where do you come from?
I'm from the past.
Imagine being able to plant crops in the morning and then harvest those crops that very night. Or how about healing a wound with a localized time acceleration device? A device that can speed up time in a small focused area, reducing the time it takes to heal wounds. Take a moment with me to imagine this world. A world where time is no longer a constraint, but a tool. Remember Back to the Future? The flux capacitor is a fictional device from the Back to the Future movie franchise that was used to achieve time travel. According to the movies, the flux capacitor is powered by plutonium and generates the 1.21 gigawatts of electricity needed to create a temporal displacement field. Sounds like a giant load of fiction, right? The truth is actually a lot stranger than fiction. Let's explore further.
And you told me the whole story. You were standing on your toilet and you were hanging a clock and you fell and you hit your head on the sink. And that's when you came up with the idea for the flux capacitor, which is what makes time travel possible. Great Scott!
Not sure if I'm going to be able to do a pre-show stream, but I will try to if possible. And with that, I thank you, have a good evening, and see you next time.